large organizations are now using Git for version control, as it allows them to scale their development efforts and improve collaboration across the team. Git is constantly being improved and updated, and its popularity shows no sign of slowing down. It continues to be a popular choice for version control and is likely to remain so in the coming years. Hello everyone and welcome to this session. You are currently watching Edureka Git Full Course video. By the end of this video, you will have a thorough understanding about Git all the way from theory to the practical applications. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about Git after watching this session and wish to obtain Edureka's DevOps certification course, then please see the link in the description below. Now let's begin with our agenda, where we'll have a brief overview of what we'll be covering in the Git full course video. We'll start with the definition of Git, where we'll learn what Git is and why should we learn it, after which we will see how to install Git. Now once this is done, we will see some Git commands with examples. Next we have Git Basics. We will then cover GitHub Workflow and Git Bash. Now it's time to deep dive into the technical aspects of Git. We will start with the GitHub Repository. Now once this is done, we will then understand GitLab CI/CD pipeline, after which we will then see what is Git Branching and Stashing. We can then see some of the core concepts in Git like Git Merge and Git Rebase. We will then compare Git Merge to Git Rebase. Now after all this, we will then head over to Jenkins Git integration. After this, we will understand what is webhooks in Jenkins, followed by GitOps. We truly hope that this session assists you in getting jobs in the industry. In order to accomplish so, we will look at how a career with Git works by seeing some essential Git interview questions with answers. So stick till the end. Now let's begin with our first topic, what is Git?
So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock and 12 o'clock respectively. Now the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way, and these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of three types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file, and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. And they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch, on a project, has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates. Instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license. So you don't need to purchase Git. It is absolutely free. And since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very, very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now there are two ways in which this goes. First of all, for Windows users, you need to install GitBash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install GitBash. I'm not going to install it completely as I already have GitBash downloaded, but I'm still going to open the page to show you guys. Alright, so the latest source release is Git 2.30 0.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. Alright, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? Alright. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of Git operations. First of all, you have your git init command, which basically creates a new empty Git repository. Now this can be used to convert an existing unversioned project to a Git repository or initiate an absolute fresh Git repository. Now most other Git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using GitBash. So when I run git init, it reinitializes an existing Git repository, which I already have here. Now what this does is it reinitialized my existing Git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty Git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It will rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the README file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now, executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree. And then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So If I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you, and then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of a, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You are ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1, 2, 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now, let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files. And as you can see, only 1 file changed, only 1 insertion happened. And that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now, if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now, if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now, what is git push? This is something we will cover later in this session. Now, understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, here you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository, and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch, since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local Git repository, You can see it's already up to date. So now my local Git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So if you're going to use the push command, this command transfers commits from your local repository to your remote repository. And it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username, and password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account. And with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of Git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. Alright, so let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now, there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just another path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created when we create a new branch. It originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to git check out the branch name, which in our case is Edureka Images. And then we are going to git commit. So you have untracked files, Edureka Images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka Images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see two different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka Images into your main branch. For that, I will first check out my main branch and then merge Edureka Images with git merge Edureka Images. And as you can see, all the data from the branch Edureka Images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka Images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log. But that is like 5 commands instead of 1. Why not just use one command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command SSH-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
We will learn how to install Git on a CentOS machine. But before we go ahead, we need to install the software that Git depends on. These dependencies are all available in default CentOS repository. So let us proceed with that. I'll type sudo yum group install development tools, and here we go. It is asking for password. Press Y. In the meantime, let me tell you about the development tools. It is a predefined bundle of software that can be installed at once instead of having to install each application separately. The development tools will allow you to build and compile software from source code. So it is done now. Let us clear our terminal. And now I'm going to proceed with the second command. And here we go. It is asking for password. Press Y. Let us clear our terminal. So now we are done with the prerequisites, so we can proceed towards Git installation. To install Git, there's a command sudo yum install git, but this command will install Git version 1.7 by default. But there are newer versions of Git available, so I'm going to install those newer versions. For that, I'll use wget command. So let us first install wget tool, sudo yum install wget, and here we go. Now press Y. So we have successfully installed wget tool. Let me clear my terminal. Now I'm going to use this wget command to download a specific version of Git. Alright, so I have to first copy the link of the version of Git that I want to install. So let me show you where I'll get that link. I've already opened it in my browser. You can see you can use this particular link, and I will use Git 2.7.2. This version I'm going to use. You can select any version that you want. Alright, so just right click, copy the link location, go back to the terminal and just paste it. Here we go. So it is done now. Let me show you where it is downloaded in my machine. Here it is, Git 2.7.2 tar.gz. Let us go back to the terminal now. Now once the download is complete, we will extract the file from the downloaded git tar file. For that we will use tar command. Let me first clear the terminal. Now I'll type the command tar-zxf git to tar.gz, and here we go. So now let me show you the extracted file. Here it is, Git 2.7.2, the extracted file. Now we'll go back to the terminal and let us change the directory to Git. So for that I'll type change directory, Git hyphen 2.7.2, and here we go. Since we are in the source folder now we can begin the source build process. Alright. So for that I'm going to use a command called make configure. Let me clear my terminal, and now I'm going to type the second command. And here we go. This configure script is responsible for getting ready to build the software on your specific system. It makes sure all the dependencies for the rest of the build and install process are available. So let me clear my terminal now. So now that the software is built and ready to run, the files can be copied to their final destination. For that I'll use a command sudo make install. Here we go. This make install command will copy the build program and its libraries and documentation to the correct location. Let me clear the terminal. Now to check the version of Git that we have installed, we'll use a command git -version. Here we go. So it is the correct version, that is 2.7.2. Now before we go ahead, we need to submit some information about ourselves so that commit messages will be generated with the correct information attached. We need to provide name and email address that we would like to have embedded into our commits. For that we will use the command that I'll type. Let me first clear it. It is git config -global user.name and your name. Here we go. For the email ID I'll type git config -global user.email and your email ID. Here we go. Now to confirm that these configurations are added successfully, I'll use a command git config -list. So username is Saurabh and email ID is saurabh@edureka.com, which is absolutely correct. Alright. So now what we need to do is we need to generate a SSH key. SSH is a secure protocol used as a primary means of connecting to Linux servers remotely. Alright. So let me first clear my terminal. Now I'm going to type the command to generate the SSH key, which is SSH -keygen -t RSA -b4096 -c and your email address. Here we go. Enter file in which to save the key. So if I just press enter, it'll go to the default location. So let us do that. Enter passphrase. So if I want it to be empty, so I'll just press enter. Enter the same passphrase again. So now we have generated the SSH key. Now there's a program called SSH agent that runs the duration of a local login session, stores unencrypted keys in memory, and communicates with SSH clients using a Unix domain socket. So it is very important to ensure that this SSH agent is enabled. So let us enable it. Here we go. So we have done that successfully. Now we need to add this SSH key to the SSH agent. So let's proceed with that. Here we go. So we have done that successfully. Now we need to add this SSH key to our GitHub account. Alright, so for that I'll use this cat command. This cat command will actually read the key and it will display it on our terminal. So let me show you. So this is the SSH key that I was talking about. So now what we need to do is we need to just copy this SSH key and we need to go to the official GitHub website. So let us Google GitHub. I will go to their official website. Over here I need to sign in first. So I'll use my login credentials. After this, what you need to do is you need to go to settings over here, click on settings, and on the left hand side there's an option called SSH and GPG keys. Just click on it and you can see there's an option where my cursor is pointing new SSH key. Let us click on it and we need to add a title over here. So you can type any title you want. I'll just type Edureka and over here I'll paste the key that I've copied from my terminal. Finally, we need to add this SSH key, so I'll just proceed with that. Let us see what happens now. As you can see, the key has been created, but now what we need to do is we need to test this key. For that, I'll go back to my terminal. Let me clear it first. Now to test this SSH key, we'll use a command SSH -T git@github.com. Here we go. Press yes. So now let us go back to the website and see what change has happened. Just refresh this link. As you can see, the color of this key has changed to green. That means we have successfully tested the SSH key. Now we'll look at some of the most commonly used operations performed on Git, that is push and pull operation. Let me first clear my terminal. For that, I'll first create a folder and I will name it as Git-repo. You can name it anything that you want and I'll keep it empty. I'll go back to my terminal and I'll change my directory to that Git repo. Here we go. So now I've entered the Git repo directory. Now I need to initialize it first. So for that I'll use the command git init. So it has been initialized successfully. Now to allow GitHub to hold our files, we need a command git remote add origin. Let me first clear my terminal. Now to allow GitHub to hold our files, we need a command that I'll just type git remote add origin and the SSH link. Let me show you from where you'll get this SSH link. First we need to create a repository. So here's an option called new repository. We'll go there. We'll give a repository name. I'll just name it as Edureka-01 and I'll initialize this repository with a readme and finally create a repository. You can add a description as well if you want. Over here you can see that Edureka-01 repository has been created with a readme file in it. The SSH link that I was talking about, you can find it from here, clone or download. Just click on it. Here is a link, just copy, go back to the terminal and just paste it here. And here we go. So now we'll perform the pull operation. Alright. So when we have successfully performed the pull operation, this readme file over here will be copied to our Git repository, the local Git repository. But I want to add this thing. When you're doing it for the first time, you need to always pull files from the GitHub account to your local Git repository, and then you can proceed towards pushing your files from Git repository to the GitHub account. I hope I'm clear. So let us now perform the git pull operation. So I'll type the command for it, git pull origin master. Here we go. Now let us go to Git repo and see whether the readme file is there or not. As you can see, we have successfully performed the pull operation. The readme file is present over here. Now we need to perform the push operation. For that, I'll go back to the terminal. And what I need to do is I need to create a file in this Git repo. Alright. And I can just name it as Edureka. And I will write here, welcome to Edureka. Save it, close it, and go back to the terminal. Now over here, we need to add this file that I've just created, that is Edureka. So for that, we have a command, git add, and the file name, which is Edureka in this case. Here we go. So now what we need to do is we need to commit changes. So for that, I'll use the command git commit -m and the message you want to display. I'll just type first commit. Here we go. So let me clear my terminal now. Now we'll perform the push operation. So when we have successfully performed the pull operation, this Edureka file will appear in the GitHub account which I have created over here. So it will be present here. So let us see if that happens or not. So we'll type the command for it, git push origin master. Here we go. So let us go to my GitHub account and check whether it has been added or not. I'll refresh this link. As you can see, Edureka file has been added over here. And this is what I actually wrote, welcome to Edureka. So now we have successfully performed push as well as pull operation. Let's focus on various Git commands. So we'll start with git init command. Now git init is basically to turn a directory into an empty Git repository. Now the first thing that you need a local repository to work with. For those of you who don't know what exactly local repository is, it is basically a private copy of the whole repository, of the whole shared repository that you have. And users can perform many operations with this repository, such as add file, remove file, rename file, move file. You can commit changes, and you can do a lot of things with your local repository. So the first command that we are going to discuss is basically the git init command, which will turn a directory into an empty Git repository. So for that, I'll open my virtual machine to show you practically. If you are facing any issues in installing Git, you can go ahead and refer my Git installation video. There also, I have installed Git in CentOS version 6.5. So for now, let me open my virtual machine and I'll show you there. So guys, this is my virtual machine where I have installed Git. If you want to see the version of Git that you have installed, just type in here git -version, and it is 2.7.2 in my case. Now let's go ahead and create the directory first. So I'm going to name my directory as Edureka-repository. Now I'm going to move into this directory. So I'll just type in here cd Edureka repo. So now I have a directory. I want to convert it into a local Git repository, which is very easy. All I have to do is type in git init. And here we go. So initialized empty Git repository in home Edureka repo.git. So let's go back to our slides again and we'll see which command we are going to discuss next. Let's talk about git add now. So git add basically adds all the files to the staging area for Git. Now Git doesn't track each and every modified file. So whenever you do the commit operation, Git looks for the files present in the staging area. Only those files present in the staging area are considered for commit and not all the modified files. So the first thing you need to do is put all the modified files, all the changes that you have done into the staging area. And then from staging area, you can go ahead and make a commit, right? So the first thing is to add your files to the staging area, which is pretty easy.
all I have to do is type in git add and the file name. So let me just quickly open my virtual machine and I'll show you that. This is my virtual machine again, guys. And first, let me just create a file here. Let the name of my file be edureka.py. Yeah, let me just go ahead and type something in this .py file. So I'll just type in here a equal to 10, a small code, b equal to 20, and I'm going to print a plus b, pretty basic. Save it and go ahead and close it, right? Now what I need to do is add the changes that I've done into the staging area, right? So all I need to do is type in here git add and the name of the file, that is edureka.py. So I've successfully done that. If I want to add all the files to the staging area, then I can go ahead and type git add and a period, right? So this will add all the files that are there in my local repository to the staging area. So this was all about git records the changes made to the files in a local repository. So you have all the modified files in the staging area. So I'll just type in here git config -- global user dot name and the name of the user. So let it be Shubham. And now I can go ahead and add the email address as well. So I just need to type in here user.email and I'll type the email address in the parenthesis in the double quotes, right? So this is done. And this was done globally. Now, if I want to execute this on the current repository, what I'll type in git config. I won't use -- global. I will directly go ahead and type user.name. So let it be my name, SAURABH. And I'm gonna add my email address as well, which is saurabh@edureka.co. Done, guys. It's that easy. Now let me quickly open my slides again and we'll see which command we are going to execute next. So we've seen how git config works. Let's discuss about git branching now. Now before I proceed, let me tell you that there will be a separate tutorial video on git branching where we are going to discuss in detail about it. Here I'll just give you a quick introduction to branching. So the first question is, why do we need branch, right? So branches are used to create another line of development. And by default, Git has a master branch. So usually a branch is created to work on a new feature. So if you're working on a web application, you might want to work on the card service, right? So for that, you'll create a new feature branch or any name that you want to give to your branch. And once the feature is completed, it is merged back with the master branch and we delete the feature branch. And every branch is referenced by head, which points to the latest commit in the branch. Whenever you make a commit, head is updated with the latest commit. Let me just quickly open my virtual machine. And over there, we're going to see how to create a branch, how to delete a branch, how to rename, how to merge, and how to check out into a different branch. This is my virtual machine again, guys. And let me just tell you how you can see all the branches. So just type in here git branch and it will list all the branches that are already there. So there's only one master branch present right now. So let me just quickly go ahead and create a branch. See, there are two ways to create a branch. One way is to create a branch and then you can check into that branch. Another is you just want to create it, but you still want to be in your master branch or your current working branch. So for that, if you don't want to check in that branch, just type in here git branch and give a name to your branch. So let that be feature. Right? And if I go ahead and type git branch now, I can see that there are two branches, master and feature, right? Now I can go ahead and delete this branch as well, but let me just quickly move into this branch first. So I'll just type in here git checkout and the name of my branch, that is feature. And this will point towards my feature branch. Now I'm in my feature branch, right? So let me just make some changes in the files that are there in my Edureka repo. So you can see that I have a couple of files, edureka.py and welcome.py. So let me just make some change in, let it be edureka.py, right? So I'll just quickly type in here gedit. Again, you can use whatever editor that you want, edureka.py, and I'll just add one more variable here. Let that be 30, and I'll print one more value, that is C plus A plus B. Pretty basic. Save it and then go back. So in my feature branch, I have made changes to my edureka.py file, right? So what will be my next step is to add these changes, add the modified file in the staging area. So I'll just type in here git add and a period because I want all the changes that I made to my files should be there in the staging area. So git add and period will add all the files. Now I want to commit these changes. So I'll just type in here git commit -m and a message feature commit, right? So it is done now. I've done all the changes and I've added those changes to the staging area, and then finally I've made a commit as well. So it says 4 files changed, 10 insertions, create mode welcome.py, welcome.py. Let me just clear my terminal now. So if I want to merge my feature branch with the master branch now, first I need to check into my master branch. For that, I'll type in here git checkout master. Now it says switching to branch master from feature. Now I'm in my master branch. So now I'm going to type in here git merge feature, and here we go. So you can see that I've merged my feature branch with that of the master branch. It's that easy, guys. Let me clear my terminal now. So what I'll do, I'll quickly create one more branch, and I'll show you again how these things are happening, because there might be some confusion still. So I'll just show you again how to create a branch, how to check into that branch, how to make some changes in your local repository, add that to the staging area, make a commit, and then merge it with the master branch. So now what I'm going to do is I'm going to delete my feature branch, because I've told you earlier as well, once I've merged all my changes to my master branch, there's no point in keeping my feature branch as of now. I delete that branch, and there are a couple of options to do that. The safest one is what I'm going to tell you, right? So I'll just quickly type in here git branch -d and the name of your branch, which in my case is feature. So it has deleted the branch feature. Now there's one more way to delete a branch. Instead of -d, you can just type in here git branch -d and then the name of the branch. But this is not the preferred option, and it's not safe as well, because if you have some unmerged changes, then also it will delete the branch. Whereas if you type in here a d, it will show you an error that will say that you have some unmerged changes, right? So always prefer -d and then feature -d and then the name of the branch that you want to delete, right? So now I'm going to show you one more way to create a branch, which is called git checkout -b, and you can give the name to your branch, right? So probably I want to name my branch again as a new. Let the name of my branch be new. So git checkout -b new. So this will not only create a branch called new, but it will also check into that branch, right? So we have also switched to a new branch that is new. And over here also, if I want to make changes to my file, I can go ahead and do that. All I have to do is use any editor. Let me edit, say, welcome.py file. Welcome to Edureka. I forgot to close the quotation, so that's the change I'm going to do in this file, right? And then I'm going to git add period. Now git commit. I made a mistake there, so I'll just type in here git commit -m and let it be new, the name message. All right, so it is done now. So guys, this was all about Git branching in this video. I'll be coming up with a separate video on Git branch. So you can stay posted by subscribing to our channel to get the notification. Now what I'm going to do is I'm going to show you how to connect to a remote repository. So I have a remote repository, the GitHub account. I've created a repository there. So if I want to connect to that repository, what I need to do is I need to add that origin. So I'll just type in here git remote add origin and the SSH link that I will just show you where you can find it. So this is my GitHub account, guys, and this is my repository, that is Git Commands. If I want to copy the SSH link, I can just go ahead, copy this and paste it here. So we have successfully added the origin. Now let me just clear my terminal. So we have connected our local repository with the GitHub account. So we have seen how branching works in Git. Let us move forward and we'll see how to work with remote repositories. So over here, I've already told you how to add an origin, right? So git remote add origin. And what we did, we connected a local repository with a remote repository. So the Edureka -repo is my local repository, and a remote repository I just showed you in my GitHub account. So we have already done this git remote add origin. So now we're going to see how to clone a remote repository. So to create a local working copy of an existing remote repository, we'll use git clone to copy and download the repository to a local computer. Cloning is the equivalent of git init when working with a remote repository. Git will create a directory locally with all the files in repository history. So I'll just open my virtual machine and I'll quickly show you how you can do that. Alright, so what I'm gonna do is I'm first gonna create one more directory. So let that be mkdir, and the name of the directory, let it be git-repo, right? And let's move into this git-repo repository. So the first thing I'm gonna do is git clone and the SSH link. So SSH link, I've already shown you where you can find it in your GitHub account. Just type in here git clone and the remote repository URL, the SSH link that I was talking about. And let me show you how you can do that. And here we go. So it says cloning into Git commands. So let me see what are the files that are there now. So it says Git commands. Let me go to this Git commands. So here we have Edureka and README. And here also you can notice that we have Edureka and README. So I've successfully done that. Let me clear my terminal. And now I can go ahead and pull whatever changes I made to the file that is there in my GitHub account. So let me just show you how to do that. Suppose if I have a file Edureka, and let me just make some changes here. I'll just type in here, my name is Saurabh. So let it be like this. So let's commit changes. So yeah, now it'll be reflected in my repository. Now what I want is I want all the changes that have been made in my remote repository in my local machine. So for that, I'll just type in here git pull origin master, and here we go. So it says it has successfully done that. That means we have pulled all the files that were there in the report repository. So if I check, so I have here Edureka and readme.md files. So if I go ahead and type in gedit Edureka, let's see, all right, so I can see that the changes have been reflected. My name is Saurabh, which was something new that I added to my file. Right, so this was all about the pull operation. Now let us see how you can push changes to the remote repository. Right, so if I go ahead and make some changes, or if I create a file, let's say I create a file, touch git.py, let that be git1.py. Right, so if I make some changes to this particular file, I'll write here print I love Git, save it, close it, right? So now before we push to the remote repository, we need to add these changes to the staging area. We need to make a commit, and then only we can push it, right? So first thing, add the file name. So I'll just type in here git add. I can go ahead and type here if period. That will add all the changes made to the files in the staging area, all the files in the staging area, basically modified files. Or I can type the name of my file, which in my case is git1.py. So I'll just type in here git add git1.py. And now I'm going to commit the changes. So I'll just type in here git commit -m, give a message. So I'll just type in here remote, and it has done successfully. So now I can go ahead and push the changes to my remote repository. So I'll just type in here git push origin master, and here we go. So it says it is done successfully. Let us go back to our GitHub account and we'll see whether those changes are reflected there or not. So I'll just go ahead and run this, basically reload it. So you can see that git1.py file is added here, right? So let me just quickly go to the slides again and we'll see what all topics we have already covered. So we have seen how to perform git clone. We have seen how to pull changes from the remote repository to the local computer. We have seen how to push the local commits to the remote repository. Now let's talk about few advanced git commands. Focus on git stash, git log, git rebase, and git revert. So I'll quickly open my virtual machine and I will explain you there only. So guys, let's discuss about git stash first. So to save changes made when they are not in a state to commit them to a repository, you use git stash. This will store the work and give a clean working directory. If I have to give you an example, imagine when you're working on a new feature that's not complete, but an urgent bug needs attention. So that's when you can use git stash. Let me just quickly show you how you can use it. So the first thing I'm going to do is create a new file. So let the name of my file be stash.py. And I'm going to make some changes to the stash.py. I'll just type in here print stash is cool. Save it, close it, and yeah. Now what I need to do is add this to the staging area. So I'll just type in here git add And now let's see the Git status. So my Git status says that we have new file which are there in the staging area, that is stash.py, right? Changes to be committed. So these are the changes that I need to commit. So currently it is pretty dirty. So what I can do is I can put all the uncommitted changes to a stash. Let me show you how I can do that. Git stash -u. And here we go. Now go ahead and type git status. Nothing to do, working directory clean. So it has converted my dirty directory to a pretty clean one, right? So with the help of git stash, right? Now the modification stashed away by this command can be listed with git stash list. So I'll just type in here git stash list. Here we go. And if you want to inspect it, so you can just go ahead and type git stash and show. So you can inspect it here, right? Let me clear my terminal now. So now I'm done. I've fixed my bug. And now I'm ready to, work on what exactly I was doing before fixing that bug, right? So what I can do is I just want to type in here git stash apply. And here we go. And now if I type git status, you can see that I again got the dirty directory back. So guys, we have seen how git stash works. Now what I'm going to do, I'm going to show you how a git log and git revert works, right? So for that, I'll quickly create a new repository. So let me do that. I'll just type in here mkdir git-log. So let that be the name of my directory. And I'll go into that directory. Yeah. So now I'm going to initialize it. So I'm just going to type in here git init. It has been done. Now I will create few files here. Let that be edureka1.py. And I'll just type in here print master new technologies at Edureka. All right, save it and close it. Now I'm going to add it here, git add, and then finally commit it. -m, just give a message, and it is done now. So what I did, I created a directory, initialized it. Then what I did, I made a file inside that. In that file, I added that to my staging area. That file has been added to my staging area. And then finally, I made a commit, right? So till now, there is no problem. Now, if I type here git log, let me show you what comes. So you can see that when I type git log, there is a commit hash, right? There is a commit that has been made by author Shubham on this particular date and time, right? So this is what basically git log is. It shows the chronological commit history for a repository. This helps you give context and history for a repository. And it is available immediately on a recently cloned repository to see the history as well. Now I can provide parameters here as well. For example, I can type in here git log -before and give a date here, right? Similarly, I can tell the git log to show me the commits based on the author, right? So if I type in here git log -author and the name of the author, then it will show the logs based on the commit made by the author, right? Similarly, if I type in here -before, right, and give a date, so it will give me according to the date as well. So this is how git log works, guys. So now what I'm going to show you is how to revert to the previous commit, right? So for that, let me just make some changes to my file again. So the name of my file is edureka1.py. So I'll just type in here gedit edureka1.py. And I'll type in here one more print statement that says, don't just simply learn it, master it. Save it, close it. Now I'm going to add it to my staging area. And finally, I'm going to commit it. -m, last commit. All right. So this is done now. Now what I have to do is, suppose I have made some changes. I'm going to go back to the previous change, right? So I've made some change in my code. I've done the commit as well, but I want to go back to the previous commit, right? So for that, what we use git revert. So let me show you how you can do that. So in order to go back to the previous commit, what I have to do is just type in here git log -one line. This will give me one line. So this was my last commit. So I want to go back, right? So for that, I'm just going to type in here git revert and the hash commit hash, and here we go. So it says that revert last commit. So it has already done that. Now, if I go ahead and check my edureka1.py file, So it only says master new technologies at Edureka. So this is how you can even perform the revert operation just by using in the commit hash. So with that, you can go ahead and revert back to the previous commit. So I hope this is clear now. Let me clear my terminal. So now what I can do is I can go ahead and revert to the last commit as well. Instead of just typing the commit hash, if I just type in here git revert head, and if I quit, so it says that I've rolled back to the previous version of my file. So if I go ahead and click on ls command, and if I type in here cat edureka1.py, so I've gone back to don't just simply learn it, master it. So my last commit was basically revert operation, right? So whatever file changes that have been done after git revert will be reflected as a commit itself, right? So I hope you're getting my point. So what I did first, I created an empty repository. Then in that, I created a file edureka1.py, made a couple of changes, made 2 commits. Then I used git revert with the hash commit to go back to the previous commit, right? So with that, I got only master new technologies at Edureka. This one I didn't get at that time. Then what I did, I showed you git revert head, which will basically take the last commit, right? It'll revert the last commit. And the last commit was nothing but the revert operation that happened that actually made my file edureka1.py to go back to the previous version. So that was my last commit, right? So because of that, it has reverted back to the last commit. This is why you can see that edureka1.py file has both master new technologies at Edureka and don't just simply learn it, master it. Right, so I hope I'm clear with git log and git revert. It's very easy, guys. There's not a lot of things to understand here. It's very basic. So let's talk about rebase now. So basically rebase is again one more way of combining the work between different branches. So what rebasing does, it will take a set of commits, copy them and store them outside your repository. The advantage of rebasing is that it can be used to make linear sequence of commits. All right, so the commit log or history of the repository stays clean if rebasing is done. Right, so let me just show you how it is done. If I just type in here git rebase master, let me just go ahead and do that, git rebase master. So the current master is up to date. That's what the message pops up. So basically this command will move all our work from current branch to the master branch. They look like as if they are developed sequentially, but they are developed parallelly. All right, so let me just give you a better example of this. So I'll just create a branch here, git branch, say Edureka 010 is the name of my branch. And yeah, so if I want to go to this branch, check out Edureka 010. Yeah, I'm into that branch. And if I make changes to edureka1.py, I'm going to remove this print statement, save it, close it, clean my terminal. And I'm going to add it, git add period, and git commit -m rebase. All right, so this is done now. And now what I can do is I can go ahead and type in here git rebase master. So it says that current branch Edureka 010 is up to date. So this is how you can perform rebasing. So let me quickly go back to my slides. So we have talked about git stash, we talked about git log, git rebase, and git revert.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system. That is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the number one contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues in marketplace we won't be discussing in this video for now. The Explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an Explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub Explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the three buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the three important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository, we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository, to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer, can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this Your Profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the edit profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the README text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch. And there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch, and you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that. And everything's normal, everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my README text file. That's the only file currently in our repository. So we'll make the change in the README text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my README text file. And the third icon is a bin icon, which will allow me to delete this file. Now what we'll be working on is the pencil icon, that's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my readme text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my readme text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that will be adding to my readme text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are two radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my readme text file. Now the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button and you can see that I made my first commit 23 minutes ago and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to a branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits after which your changes are merged into the base branch. So there are two ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch 1 branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left hand side indicates the information that is present on the master branch and the right hand indicates the information that is present in my branch 1 branch. Plus sign indicates the additional information that is present in my branch 1 branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch 1 branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request and I'm going to confirm my merge, update my readme text file. I'm happy with that. So I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch 1 branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch 1 branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now, if I switch to my branch 1 branch, it has the exact piece of information. So the information that was present in my branch 1 branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the internet protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing. What is a workflow? Workflow is about controlling the sequence of events that transform a piece of work to ensure every person on the team can use the best tool at the right time. To put it simply, a workflow is how you get work done. It is a series of tasks you need to complete in order to reach some repeatable business goals. At its core, the workflow is change management. As I have already mentioned before, workflow comes in all shapes and sizes. There is no universal solution for every team's needs. An optimal workflow enables the systematic organization of resources into processes that transform materials, provide services, or processes information. The principal ways to manage software in Git are the Git Flow and the GitHub Flow. These two methods can really help you to manage your project and optimize your entire workflow in the team. Now that we know what is a workflow, let us discuss about Git Flow versus GitHub Flow. So first we'll discuss about Git Flow. Git Flow works with different branches to manage each phase of the software development. It is suggested to be used when your software has the concept of release, because it is not the best decision when you work in a continuous delivery or continuous deployment environment where this particular concept is missing. Another good point of this flow is that it fits perfectly when you work in a team and one or more developers have to collaborate on the same feature. So the main branches in Git Flow are master, develop, features, hotfix, and the last one is release. Now let's discuss about GitHub Flow. GitHub Flow is a lightweight branching workflow that supports teams and projects where deployments are made regularly. It is centered around a particular feature and small confined changes. So now I'll discuss some of the key features of GitHub. Here the master branch is always production ready. Master is also deployed to production. Development often only happens on the feature branches. The deployment speed is extremely fast here. And the last important feature is that it requires a verification for each release. Now let's move on and discuss some of the major issues of Git Flow. So here many of the developers do not like that new feature branches are started off the develop branch rather than the master branch, or the way it handles hot fixes. But these are fairly minor issues. But before we move on with the major ones, let me explain you what are hot fixes. Hotfix branches are a lot like release branches and feature branches, except they are solely based on master instead of the develop. This is the only branch that should fork directly off of the master. Now moving on to the major issues with Git Flow, it is much more complicated than most developers and development teams actually require it to be. It's complicated enough that a big helper script was developed to help enforce the flow. Though this is okay, the issue is that it cannot be enforced in a Git graphical user interface, but only on the command line. So the only people who have to learn the complex workflow really well, because they have to do all the steps manually, are the same people who aren't comfortable with the system enough to use it from the command line. This can eventually be a huge problem. These issues can be obviously solved easily just by having a much more simplified process. So here at GitHub, they do not use Git Flow. They use a much simpler Git Workflow. Its simplicity gives it a number of advantages. One is that it is easy for people to understand, which means they can pick it up extremely quickly. And if they ever mess up, they can always undo. Another is that we do not need a wrapper script to help enforce it or follow it. So using graphical user interfaces and such are not a problem. So the next question that arises is, why don't they use Git Flow at GitHub? Well, the main issue is deployment. The Git Flow process is designed largely around the release branch. GitHub does not really have the releases because your deployment to production occurs every day, that is often several times a day. The process of testing and shipping is as simple as possible so that every employee feels comfortable doing it. Now let's move on and understand the main topic of today's session, GitHub Flow. The first step in GitHub Flow is to create a branch. So when you're working on a project, you're going to have a bunch of different features or ideas in progress at any given time, some of which are ready to go and others which are not. Branching exists to help you manage this particular workflow. So now when you create a branch in your project, you're creating an environment where you can try out new ideas. Changes you make on a branch do not affect the master branch, so you're free to experiment and commit changes, safe in the knowledge that your branch won't be merged until it is ready to be reviewed by someone you're already collaborating with. You can always switch branches using the git checkout command. Now, branching is a core concept in Git, and the entire GitHub flow is solely based upon it. There is only one rule: anything in the master branch is always deployable. You should remember this. So because of this, it is extremely important that your new branch is created off the master when working on a particular feature or a particular bug fix. Your branch name should always be descriptive, so others that are working with you can see what you're working on. Now let's move on to the second step in GitHub Flow: add commits. So once your branch has been created, it is time to start making changes. Whenever you add, edit, or delete a file, you're making a commit and adding them to your branch. This process of adding commits keeps track of your progress as you work on a particular feature branch. Make sure you are on the correct branch by listing it, and if necessary, switching to it by using the command git branch and then using the next command git checkout your feature branch name. Make sure you are on the current branch by listing it using the git branch command, and if necessary, switching to it by using the checkout command. Commits also create a transparent history of your work that others can follow to understand what you've done and why. Each commit has an associate commit message, which is a description explaining why a particular change was made. Furthermore, each commit is considered a separate unit of change. This lets you roll back changes if a bug is found or if you decide to head in a different direction. You can do this by adding, committing, and then finally pushing it. Commit messages are extremely important, especially since Git tracks your changes and then displays them as commits once they finally push to the server. By writing clear commit messages, you can make it easier for other people to follow along and provide feedback. The next step is open a pull request. Pull requests initiate discussion about your commits. Because they are tightly integrated with the underlying Git repository, anyone can see exactly what changes would be merged if they accept your request. You can open a pull request at any point during the development process. When you have little or no code but want to share some screenshots or general ideas, or when you're stuck and need some help or advice, or even when you're ready for someone to review your work. By using GitHub's @mention system in your pull request message, you can simply ask for feedback from specific people or teams. So in pull request, you can also describe how to test your changes. Pull requests frame a problem by describing it. Maybe you're trying to fix a bug, add a feature, or trying out a new code pattern. Having a proper problem description ensures that your reviewer knows exactly what you're getting into. To let your reviewer know how to run your code, describe how to test it properly. Lay out a scenario that gives a basic run-through from setup to the expected outcome. Are there any multiple angles you can test your feature with? Awesome. Specify a test case for each scenario. Not only does this help your reviewer navigate through your code, it also helps you. By describing the feature step by step for someone else, it ensures you have not missed anything critical. Now let's move on to the next step, that is, discuss and review your code. Once a pull request has been finally opened, the person or team reviewing your changes may have questions or comments. You can obviously read these. You can also continue to push to your branch in the light of discussion and feedback about your commits. If someone commits that you forgot to do something, or if there is a bug in the code, you can immediately fix it in your branch and push up the change. GitHub will show your new commits and any additional feedback you may receive in the unified pull request view. Pull request comments are written in Markdown, so you can embed images and emoji, use pre-formatted text blocks, and other lightweight formatting. You can even suggest committable changes right in the comment. A review basically focuses on the code health and on production readiness. So let me explain you what code health is. Perhaps the coding style does not match project guidelines. The change is missing unit tests, or maybe everything looks great and props are in order. Pull requests are designed to encourage and capture this type of conversation. You can suggest changes directly in a comment by hitting the Suggest Changes option. Now let me explain you what production readiness is. The pull request template lays out one or more scenarios on how to test your code. The reviewer will go through a scenario and document the results and whether or not the test is passing. The reviewer should be generous with comments, descriptions, and screenshots. Also ask for any sort of explanation or improvements as the test is progressing. The reviewer will also describe if the test scenario passes. With this, we'll move on to the next step, that is test your changes. So before any code is finally deployed into production, it needs to be tested in a production-like environment. That is, you could say the staging area. To make your life easier, read upon how to make an update script to update your tool for each environment right here. With this, we come to the last step of GitHub Flow, that is merge your feature. Now that your changes have been verified in a production-like environment, it is time to merge your code. Make sure the code has been signed off before proceeding. Squashing commits of a pull request improves the readability of the commit history. So during development, commit early and often. Once your work is ready, merge with the focus commit message. By default, the merge button for repositories will be set to squash and merge. Once merged, pull requests preserve a record of the historical changes that is made to your code. Because they're searchable, they let anyone go back in time to understand why and how a decision was made. What is Bash? In the early days of computing, the computer that processed data or performed operations was separate from the tool that gave it the instructions to do the processing. On one hand, there was the terminal, which was used to send commands to the computer, and on the other hand, we had the computer, the hardware that processed the commands. Today, there are computers that can provide both commands and perform the computation, and these computers have graphical user interface that make it easy to perform tasks. However, accessing the command line or terminal can often be more efficient than using graphical user interfaces for certain tasks, and you can send commands via the terminal to programmatically accomplish these tasks. Now, for example, working with files in the terminal is much more faster and efficient than working with files in a graphic environment like Windows Explorer or the Finder on a Mac. You can also use the terminal to launch and execute open reproducible science tools such as Jupyter Notebook, Python, and Git, which we will talk about later on in the session. Before we really understand what is Bash, we need to understand what is shell. So shell is the program and the information produced is the output. Now these commands can be entered and executed via the terminal, which allows you to control your computer by typing in commands with the keyboard, instead of using buttons or drop-down menus in a graphical user interface with a mouse or keyboard. Bash, also known as a born-again shell, is an implementation of shell which allows you to efficiently perform many tasks. Let me explain Bash with an example. You can use Bash to perform operations on multiple files quickly via the command line. You can also write and execute scripts in Bash just like you do in R or Python that can be executed across different operating systems. Using Bash in the terminal is a powerful way of interacting with your computer. GUIs and command line Bash are complementary. By knowing both, you will greatly expand the range of tasks you can accomplish with your computer. Now, with Bash commands, you will be able to perform many tasks more efficiently and automate and replicate workflows across different operating systems like Linux, Windows, etc. Now, common tasks that you can run at the command line include checking your current working directory, changing directories, making a new directory, extracting files, and finding files on your computer. Now, working in the terminal with Bash provides you with the ability to easily navigate your computer to access and manage files and folders. That is, you can easily navigate your computer's directories. You can also quickly and efficiently work with many files and directories at once. Also, you can run programs that provide more functionality at the command line, like, for example, Git. You can also launch programs from specific directories on your computer, for example, Jupyter Notebook. And finally, with the help of Bash, you can use repeatable commands for these tasks across many different operating systems like Windows, Mac, and Linux. Now that we know what is Bash and we've also discussed some of its features, let's move on and understand what is Git Bash. Git Bash is simply an application that provides Git command line experience on the operating system. The operating system can be anything as usual like Linux, Windows, Mac, etc. Now it is a command line shell for enabling Git with the command line in the system. A shell is a terminal application used to interface with an operating system through written commands. Git Bash is a package that installs Bash, some common Bash utilities, and Git on a Windows operating system. Now in Git Bash, the user really interacts with the repository and the Git elements through the commands. The next question that really pops up in your mind is, what is Git, right? So Git is a version control system for tracking changes in source code during software development. It is basically designed for coordinating work among programmers, but can also be used to track changes in any set of files. So basically, its goal is to increase efficiency, speed, and easily manage large projects through version controlling. Every Git working directory is a full-fledged repository with complete history and full version tracking capabilities, independent of network access or a central server. Git helps the team cope up with the confusion that really tends to happen when multiple people are editing the same files. Now that we know what is Git, Git Bash, let's move on to the demo part and learn how to install Git Bash for Windows. Now let's download Git for Windows. I'm just going to Google GitBash for Windows and I'm going to click on the first link. This will redirect me to the Git's official website where I can download Git, and I'm going to click on Windows option here. So once you click on the download link for Windows, it will download the executable file. Now that it has installed, we can extract and launch the Git installer. I'm just going to click on this folder. Now you can just review the GNU General Public License, and once you're ready, you can just click Next. The installer will also ask you for an installation location. You can just leave the default unless you have any reason to change it, and then you can click Next. Once you click Next, you'll be prompted with the component selection screen, and you can just leave the defaults unless you have a specific need to change them, and click Next. Now the installer will offer to create a start menu folder. Just you can click Next. Now you can just select a text editor you'd like to use with Git. Use the drop down menu to select whatever you'd need for your convenience. I'm going to be selecting Notepad++, and then I'm going to click Next. If you do not have Notepad++ installed onto your system, you can just click this link and then just install it. It'll take you a minute. Then just click on Next. Now this installation step allows you to change the path environment. Path is the default set of directories included when you run a command from the command line. Leave this on the middle, that is recommended selection, and then you can just click Next. The next option relates to server certificates. Most users should use the default. If you're working in an Active Directory environment, you may need to switch to Windows Store certificates, so you can just click Next. Now the next selection converts line endings. It is recommended that you leave the default section. This relates to the way data is formatted, and changing this option may really cause problems, so you can just click Next. Now you can just choose the terminal emulator you want to use. The default MinTTY is recommended for its features. You can just click Next. In this option, you can choose the default behavior of Git pull. I'm just going to leave it as default and click Next. Now here you can just choose a credential helper. I'm just going to let it be on default. Click Next. I'm going to enable file system caching. I'm going to click Next. Now currently the option to include interactive options is offered here. Unless you're feeling adventurous, leave them unchecked and then just click Install. Now once the installation is complete, tick the boxes to view the release notes or launch GitBash, then just click Finish. And as you can see, Git has launched the release notes. I'm just going to open this. You can just read the release notes. I'm just going to close that window. Now Git has two modes of use. Okay, the first one is a bash scripting shell, or you could say the command line, and a graphical user interface. Now in this tutorial, we're going to be using the bash scripting shell, that is our command line. Now to launch Git bash shell, you can just open your Windows Start menu and type Git bash. Okay, and this will take you to your Git bash. I'm just going to zoom in. Yes, perfect. Now, if you'd want to create new directories, that is just folders in Git, you can just use the mkdir command. Now, I'm just going to create a new directory named git_demo. Now, I can change the location to the newly created directory by using the command cd and type the name of the directory that I'd like to move in. That's git_demo. And you can see that I have moved into my git demo directory. Also, you can use the ls commands to list all the files and folders in the current directory. I'm just going to type ls. Because it has none, it's not going to show you any. Now, if I'd want to move back to my previous directory, I can just click on the cd command and put in 2 dots, and this will take me back to my previous directory. And if I click ls, you can see all of the documents that are currently present in my directory. You can see that I have pictures, I have videos, I have Anaconda, I have a folder named Git Demo. This is great. Okay, now what I want to do is I want to create a username and I want to create an email for working on Git Bash. And for this, I can use the command git config --global user.name. And I'm just going to type in my first and last name. Okay. And this has created the username for me. Now I want to set my email address. So I'm just going to type the same command, but I'm going to refer this to email. And I'm just going to type in my email. Okay. Once that is done, I have set up both my username and email. Now let's move on to the next part of this session and learn how to initialize a local repository. Okay, so now what I'm going to do is I will clear my screen. Now what we've really done is we've set our Git username for every repository on our computer. And once that is done, I just want to check if the username has been set. I'm just going to use this command. Now that I have confirmed I have set my Git username correctly, let's move on to the next part. So firstly, let me clear my screen for this. Now there are some few basic commands that you have to be familiar with when you start off with Git and GitBash. So I'm going to be talking about some of those commands. The first one is who am I? Now the command's output is the ID of the current user. When you type who am I, the shell finds a program called who am I, runs that particular program and displays that program's output, that is your username, and then eventually displays a new prompt to tell us that it is ready for more commands. Now let's try another command, that is pwd, which stands for print working directory. Now when you first log in, right, your current working directory is your home directory, okay? And your home directory has the same name as your username, and this is where your personal files and subdirectories are saved. So pwd is that. And as I've already mentioned before, to find out what is currently in your home directory, you can use the ls command. And ls just prints the names of the files and directories in the current directory in alphabetical order, arranged neatly into columns. Now, the number of commands have extra options or features which we can call through the use of a flag. Now, a flag is usually a dash followed by a single letter such as -v, -l, etc. I am just going to type the command ls-l. Okay. So the -l flag on the ls command is short for long format, and it really displays a more detailed listing of all the files within the current working directory, including file size and the date of its last modification. Now you have to remember that there is a space between ls and -l. Without it, the shell thinks we're just trying to run a command called ls-l, which doesn't really exist. Let's take another example of the flag. I'm just going to type ls-f. Okay. Now this command tells ls to add a trailing to the name of the directories. Here we can see the list of all the subdirectories that are present. Now fields like links, music, all of them have trailing slashes. And there are a ton of online manuals that really tell you which options a particular command can take and how each option modifies the behavior of the command. Now I'm just simply going to clear my screen. And one more thing I forgot to mention is that if you want to check that Git is up and running and is installed properly, you can obviously use the git help command, and it will just give you an overview of what is in Git and if it's up and running. Now we will just move into the directory Git demo. So I'm just going to use the change directory command, and this will just move me to my Git demo directory. Now I will tell my Git to create a repository. Okay, for all of y'all who don't know what a repository is, it is a storage area where a version control system really stores all revisions of files and information about who changed them and when did they change them, etc. It's basically a storage space for your file, okay? And each version of the changes that you make in these files are stored in a repository. Okay, that's what a repository is. Now let's move on and initialize this repository by using the git init command. It'll prompt you with a note that says initialize empty git repository in this particular location. Okay, so that's great. Now let's look at what is in our directory. You don't have anything. And as you can see that this is currently the master branch that we're working on. So the master branch is the main branch of your repository where all of the changes to your project is directly implemented. Okay. So branches is completely a different topic on its own. So we'll not really talk about it in detail. So I'd like to talk a little bit about the init command. So the initialization command really creates a hidden directory. And you can see that it has created a hidden directory that is named as .git. Okay. Now Git really stores information about the project in the special .git subdirectory. Now, if we delete this file even by mistake, what really happens is we lose the entire project's history. Okay. So the next command that we'll be learning about is the git status command. I'm just going to click enter. And you can see that it says on branch master, no commits yet, nothing to commit. Okay. Now, first of all, this gives a lot of information, right? It states that firstly, we're located on the master branch. So we haven't made any commits yet. Commits just allow you to save the progress of your files on Git. So as we have not made any commits yet, it just indicates that. So we haven't created any files. So it says nothing to commit. And I'm just going to clear my screen. So now what I'm going to do is I'm going to create a file using the touch command. I'm going to name this file demo2. So basically this is a text file. So I'm just going to add the extension .txt and I'm just going to list. Now you can see that this directory has a file, a new file, which has been named demo.txt. So now we're going to use the command git add demo.txt and then check the status of Git. Now you can see that there's been a change, right? So in the third notification, you can see that changes are to be committed to the new file demo.txt. Okay, so this is great. What we're going to do is now we are going to commit this. So before I commit it and save it, I'm just going to explain you what use get rm -- cached file to unstage means. So this command really removes your current file from the staging area. Okay. Currently, our file is in the staging area, so we're just going to commit it by using the command git commit. And if you'd like to add a message, you can just use the -m, open the semicolon, and type your message. So I'm just going to type first commit. Once that is done, you can see that our first commit has been successfully made and one file has been changed. There's 0 insertions and 0 deletions. You can check the status again. You can see that nothing is there to commit and the working tree is clean. So this is how Git really works. The Git cycle works. This is the basic structure of it. Once a directory is set up as a Git repository using the git init command, any change that we make to that directory is noted by Git. So the first is you either create new folders and files in your directory, or you can even modify it. We haven't done that yet. And the second stage is you stage these changes ready to commit by using the git add command. And then finally, you commit the changes using git commit, which permanently saves the current version of that repository. So these are the major 3 steps. You create new folders and files, you stage them by using the git add command, and then you finally commit these changes. So now that we know the basic commands of Git, let's move on to the next part of the session. I'm going to clear my screen. So version control really comes into its own when we begin to collaborate with other people, right? In practice, groups like to use a central hub or a cloud stored on the web rather than on somebody's laptop so that all the collaborators can easily access the repository. Git is very popular because of websites like GitHub, Bitbucket, which make collaboration extremely easy. Now, what we're going to do is we are going to go to GitHub. So in short, GitHub is really a web hosting platform for you to collaborate with other team members. And I'm just going to sign in because I already have an account on GitHub. I'm just going to sign in. I'm going to enter my credentials. That is my username or email address and password. If you do not have a GitHub profile, I would suggest you to create a new account. It's really easy. And I'm just going to sign in. And this will redirect you to your GitHub account. You can see that you have a navigation bar on the top, which has some options like pull request issues, marketplace, explore. You can also check out your profile, your status, your projects, and all the repositories that you're currently working on GitHub. Okay, so what we're going to do now is we're going to create a new repository. So what is the difference between the repository that we created on GitBash and the repository that we're going to create on GitHub? So the one that we created on Bash is a local repository that is solely for your local machine that you're working on. But the repository that we're going to create on GitHub is on a central repository. So when you create this repository, the team members, your friends, your family can really look into this repository and look at all the files and folders that are present on your GitHub repository. Okay, so we're just going to create a remote repository. I'm just going to name this repository demo, and you can add a description to your repository if you'd like to. Also, I'm just going to add a README file, and then I will create repository. Now, once this is done, I'm just going to click on this green button that says code, and this will give me an HTTPS link. I'm just going to copy this link. What we're really going to do is we're going to connect both of these repositories. We can do this by making the GitHub repository a remote for the local repository. Okay. Now, the homepage of the repository on GitHub includes the string we need to identify it, which we've already copied. Now, since we've already created a repository on a local computer, we're interested in the instructions in the second box. So we're making sure we are in the demo directory locally. And we're going to do this by using the command git remote set -URL origin. And we're going to paste the HTTPS URL that we've copied from GitHub. So we click this code and then we copy this HTTPS link. So that's exactly what we're going to do. We're just going to add that and click enter. So what really this command does is it tells Git to add a remote named origin at this particular URL. Fine. I hope this is clear. Now you must be wondering what is the keyword origin. Okay. So this is simply a nickname that we've assigned to the particular remote repository. We could have it called anything, but origin is the most common choice for programmers. Now, if we have to check the command worked, right? So we're just going to use the git remote -v. Now that you can see, it lists all of the remote repositories that are present on my GitHub profile. Now the -v flag is short for verbose, which really tells Git to show the remote URL as well as the nickname. So far what we've done is we have set up a remote repository and linked it to a local repository. So the remote repository currently is empty. It doesn't have any files. It just has a README text file. I want to add my demo.txt file that is present on my local repository into my remote repository. That's what we're going to do. And we can do this by, pushing the changes from our local repository to the repository on GitHub. We can use the command git push origin master. And this will pop up a window which will allow me to connect to GitHub. Okay, you can either connect to GitHub with the help of a personal access token, or you can also sign in with your browser. I'm just going to sign in with my browser. You can see that you can just authorize Git credential manager. The authentication has succeeded. So now our local and remote repositories are synced. So that's great. Now you can just view that the files have been reflected into our remote repository. And if I click on the master branch, which is the name of the branch that we were currently working on our local repository, we have a demo.txt file. You can quickly switch back to your main branch too, and you can see the README file that was created initially on a remote repository. So this is how simple it is to work with GitBash and also with GitHub. It's really easy. It's really interesting. I hope you had a great time understanding the basics of GitBash and how it really works and what it is all about.
How do we configure remote repository on a local machine? What we are trying to do is that we have an existing project on our local machine and we have not added the git remote. So what we're going to do is we will adding the git remote. So if I go back to git ls, if I do git remote, then there is none. So what I'm going to do is I'm going to copy the remote URL from here and I'll go to this project, hello world. I'll copy the remote URL and I have to execute this command git remote add and then the remote name and then the repository name. So what I'm gonna do is origin and this is my repository URL. So if I now do git remote, I should see now origin. I can also see it verbose. Let's see. So remote name is the name for the remote and the remote URL is the remote repositories URL that I just copied from the GitHub. I can see the detail link between the remote repository name and the URL, which is here. So I have my origin, and this is my remote URL. For push, it is also the same. This is another demo we are doing, wherein we are configuring existing project as a remote repository. So what we are going to do is we are going to create a new repository on GitHub. We'll open the Git Bash and initialize a project. And once that is initialized, I'll add all files in the local repository by adding git add dot. Then this is stage file for the first commit. So once that is there, I'll make my first commit as git commit -m, and then we will add the remote. So I'll start with this. So let's create a new repository on the GitHub. I'll go to new repository. This is public, and I'll initialize with read_md, and I'll take the license as general public. So I'm creating my repository. My repository is created. Now I can go back here and so I'll create new project, my project 2. I will add a new file, test.txt, and I'll initialize my directory. So I've initialized the directory. I can look at the Git status now. So I have untracked file. I'm gonna add it. This is my first commit. So I'm committing this file from staging area to the repository. Now this is committed. Now what I have to do is I'll add a remote repository. So if I go do git remote to look at the repositories, then they should be none. So what I'm gonna do is I'm gonna copy this remote URL, repository URL. I'm gonna do git remote, add the name, and then the git. Now if I do remote -v, I have my git ready. Now git push origin master. So what we did is we didn't integrated the remote changes. So before this, the push, I'll have to do a pull here because we have readme.md file. So I have my so what it did is there was some issue with my branch. So what I did is I just rebased my branch, and if I look here, now I'll do is I'll push it to the origin master. So now I have uploaded the project. So what we did is we created a new project, and when we uploaded this file, we added the remote URL, remote repository URL, and we have uploaded the file. So we can see the remote repository that we already knew, that we can type git remote and do -v, and it will show us the URLs that Git has stored. It will list all the remote servers which are there. So this is what we are talking about. Git remote, I can get origin, and if I add -v, I can get all the URLs. I can also rename a remote repository. For example, instead of origin, I want to, for example, if I have different remote repositories, then I can, for example, name it something else. So what I'm going to do is I'm gonna rename the origin to repo1. If I do now git remote, so I have repo1 now. So this is just for the renaming a remote repository name. Now to remove a remote repository, we can use either of the below options. So they're both the same commands. First one is git remove, and the second one is git remove rm. These two commands. The reason for removing can be that maybe the server has moved and we are not using that particular mirror, or our contributor is not contributing anymore in the project. So there can be n number of reasons for removing the branch. In case the server has been moved, then we first remove the remote repository, and then we will add the remote repository again that we saw in the previous examples. The point here to note is that all remote tracking branches and configuration settings will also be deleted for that particular remote repository. So how can we check the remote repository? So I'm going to again do git remote -v. So I have the git repository named origin with the git URL is listed. So to remove it, what I can do is I can either use git remote rm and then the branch name. Now if I check this again, then this will return me a blank result. So now let's take an example. What I'm going to do is I'll quickly remove my module 3. So I'll quickly clone this. This is the same we are using. Since I have removed the remote, instead of adding the remote, cloning is much faster for me now. So I'm gonna get into this, and this is, I have the remote available. So what I'm gonna do is, let's check the branches and then execute the command. So we have only one branch, which is master, which is the default branch. So now I'm going to create another branch. Let's name it as old branch. Well, now since we will cover this in more detail in the coming slides, but for now, you have to understand that when I execute the code git branch old branch, or the branch name, then this branch is created on the local module. Then this branch is created on my local repository, and I have to push it to the remote repository. So the command to push it is git push, then the remote repository name and the branch name. So this branch is moved. I'm gonna open another window for Chrome. And now what I'm trying to do is, we're going to go to the GitHub and see if the branch has been created successfully or not. So I'll go to my repositories, module 3, and yes, there's an old branch, right? Now since we have the old branch available on git remote, so now let's remove this branch or delete this branch, and the command to delete is same. The only thing that I'll add is, I'll add dash dash delete after the repository name. So git push origin dash dash delete old branch. So let's go back again to this and see if the, so now I have only one branch, which is master. Let's create another new branch, and let's, sorry, not the push, but I'll have to first create it. So I'll do git branch new branch and then git branch. This will show the new branch. Okay, the point here to note is that, as I said, when I deleted the branch from the remote, then it was only deleted from the remote. If you can see here, there's only one branch, and this old branch is not deleted from the repository. To delete this branch completely, or any branch completely, the steps will be: first to delete it from the remote, second to delete it from the local. So to delete it from the local, I'm going to do branch -d and the old branch name. Now if I do git branch, I only have one branch, which is git. And now I'm going to push this new branch again to origin and then the new branch name. Yes, so now I have another branch, which is new branch. Now I can also go ahead and rename a branch. So to rename branch on the remote repository, you need to first rename a branch on the local repository. Once that rename is done, you will then push it to remote with the same name for commands. So let's check this. For example, here what we're doing is, we are checking out a new branch. We're creating a new branch, old branch, and at the same time, we're also switching that branch again. So this whole one single step can be broken down into two. Number one, we create a branch with git branch old branch, and number two, we switch to the old branch using git checkout old branch. But this single command will do the both thing. It will create a new branch and then switch it on it. So if I do git branch, then I have only new branch. So let's do git checkout. So you see, it has created new branch and switched to it. But this is the local branch. This branch does not exist on the remote so far. There is only new branch. There are two branches, master and new branch. Next, what I'll do is, I'll push this branch to the remote. So the command is same, git push the remote repository name and the branch name. Okay, now I have three branches: master, new branch, and the old branch. And if I do this command, before I rename, so let's rename it to, here what is happening is that when we create this branch, we had only two branches, master and old branch, and then they are renaming this old branch to new branch. So let's rename this old branch to actually new branch name, new branch 1. So the command is git branch -m, the old branch name, and then new branch 1. If I do now git branch, then I have again three branches: master, new branch, and the new branch 1. But if I go to the remote again, then I have not pushed this change to the remote yet. So I have only three branches: master, new branch, and old branch. This has not been renamed on the remote. So to rename it on the remote, what I'll do is, I'll push this branch, git push, and what I'm going to do is git push colon if we now go to this branch and let's check the branch name, so the old branch name has now been changed to new branch 1 on the remote as well. While if we go to this example, then what is happening is that we have created a new branch, new temp, and then switched to that branch. So the -m option here is for moving or renaming a branch. So generally the command follows this get branch -m, the old branch name and the new branch name. If we go and try this example, then get branch -m, let's call it temp, yes, new temp, and then we are gonna move temp to new temp. But the issue here is that they already have temp. So let's create first of all temp here. Okay, if I do now git branch, then I have temp. So the first command, what happened is, if you remember, our new branch 1 has been renamed to temp. So if I'm not providing the second argument, it will consider the default branch which is selected or the current branch which I'm on as the branch which has to be renamed. Now if I'll move temp to new temp, if I do now the git branch, then temp has been renamed to new temp. In the last step, I'm pushing this, but let's see if it will push or not. But I think it will. I'm not sure if it will work because we don't have the temp on the remote. Let's see. It has failed to push. Why? Because I don't have the new branch. I have not pushed the temp. So let's rename this to temp again. And then let's push new branch 1 to temp. So now I have the command temp now, or sorry, the branch name temp. And now if I move this temp to new temp and then push it to the remote repository, then this will work as well. In the same way, we can delete the remote branch. We already saw this example, but let's now delete this branch that we created. So the command is dit push, then we pass the -delete option and then the remote repository name and then the branch name. So -d origin new underscore temp. We'll again ask for password. If you are working on remote, I strongly suggest that you should consider setting up the passwordless SSH. So this branch is now deleted. Let's verify it. Yes, now we have two branches, master and new branch. We deleted the new temp. Now this is the another option we have in when we are pushing our changes to the remote, which is the -f or the force push flag. So git push -f is a short for git push -- force option. If I go and we can try up. So this is the option we are talking about, force. So this option will force a push when otherwise Git would reject your git push because you might have changed your repository history in pushing your repository. So force push also lets you overwrite someone else's commit which have been pushed after your last pull. For example, let's consider that your repository is at commit A and you change something locally and committed. So this now becomes the commit B. You push commit B to your remote repo. So both are now B now. Now you decide to change something again and replace your commit B by commit B hyphen. Now you want to push your commit B hyphen changes to the remote repository. A plain git push will not work. So you can now remove commit B from your remote repository and push B hyphen instead with git push -- force. So what will happen is it will override the changes and will replace your branch directly. Be aware that force pushing is a highly dangerous and unclean solution when you are working in a shared repository. So instead of you, someone else might have pushed, for example, B hyphen, and if you're trying to commit now B hyphen hyphen, then you'll get a merge conflict. And in that case, to resolve the merge conflict, you can overwrite your changes. However, that is not recommended and that is unclean. So all commits in the shared repository should be considered immutable. This is the best practice. And to keep your repository consistent and keep your coworkers happy, you should use git revert instead. Or you should go for manually merging the conflicts, which we'll see in the next module. So let's try this git push example. Let's see how the git push will work. So what I'm gonna do is I'm gonna go to test.txt and let's update some content in it. It says edit from remote. Let's change it to remote 1 another line from GitHub. Let's commit those changes. So what is happening now, I have a different version on the remote, which we can consider that someone else pushed it, and we have a different version on the local. So now let's update our local repository. Please note that we are not merging the changes. We are only updating our local repository. I'm assuming we were on master, yes, and git branch. So let's check out the master as well. So now I have also fetched the master repository here. Now you can see that my changes are there, but they are not been pushed into my file yet or merged into my file yet. I still have added from remote, but not that. So if I go ahead and change my repository, for example, let's change the test.txt. Before that, first check the status. So there's nothing to commit, we are clean. So let's edit test.txt and let's add this line. This is added from local repository. I'm again saying I'm using Emacs editor here. If you are comfortable with Vim or Nano, you should go ahead and use that. Now what I did is I updated the file, but that is not in the staging area yet. So let's move it to the staging area. Now it is in stages, and now I am gonna commit it. Added line from local repo or workspace, I can say. So now we have our remote is on different commit and my local is on different commit. So what I'm going to do is now if I go ahead and if I try git push origin master, then this will be rejected. So okay, it's authentication fail. Let me try it again. So this is rejected. Why? Because the tip of my current branch is behind its remote counterpart. So we have to integrate the remote changes before pushing again. So now I have two options. Either I merge them manually, which is called as the merge conflict, which we'll see in the coming slides. But for now, we can have an unclean solution, which is overwriting all the changes. So what I'm going to do is I'm going to just add a force option here before the git. So not after the git, but after the git push. So you see now my changes have been pushed here, and this changes another line for GitHub has been removed completely. So it has overwritten my file. If I go to the history, then I can see that I have this added line from the workspace, but I don't have that change wherein I added line from the local from the GitHub. Once we have merged the force update, or once we have did the force push to the repository, let's look at the file locations in both pre and post commit. So any file can exist in three locations, which we already know what this location are, and the same file can have different content and different locations. So the first one is remote inside the repository. So this is the remote, which is, for example, is in GitHub. Second is stage in the index. So this one is ready for commit and is the staged area. Third is the workspace, which is not in the staged area, but it is in a workspace so far. So content of these file as it was last committed to the repository. This is in the repository. This is on our local, but second one is in the stage and ready to commit, while the first one is not a stage yet. And most files are in progress state. Git won't do an auto update for a stage file with additional edit. To do that, we need to explicitly add our files from the workspace to the staged area using the git add command, which we already saw in the previous examples. The next thing we have is compare remote repos. So we already saw how the conflicts can happen. So this comparing the remote repository will come in handy with the conflicts when we'll come to that, but we can also compare our file with the remote one, or between the two locations, or between the two files, or commit hash, different options. If we do not specify any option, then it will compare to the staged or the index version. To compare the stage version with the committed version. So committed version is what is in the remote area. We have to use -- staged. Additional different option are comparing file within two files on the disk, comparing with two commits, or comparing file without any commit. So the command is git diff, which is this. Let's look at the help for git diff. So this will show changes between commits, commit, and the working tree, etc. We have different options. Options can be -- cached, and we can compare different files. So let's do a specify the first thing. So let's compare. We are not providing any option, the workspace to the staged version. So let's do git diff test.txt. First edit our test.txt. If I look at the status now, we have up to date, right? So let's edit test.txt and let's add this. This line is for git diff. Now let's compare this file. So if you see, we are comparing it with the index version. We have A, B, and we have added this line. This line is for git diff. This will appear in the green color. But if I go ahead and remove the line, and if I do git diff, then what is happening is I have a red color which is saying this line has been deleted, and I have a plus color. There is a blank line inserted, and then there is another line inserted. Now what I'm going to do is I'm going to add this to the staged area. If I look at the status now, then this is added to the staged area. Now if I do git diff, then there are no changes because I'm comparing test.txt to one that is staged. To compare it with the remote, I have to use cached. This is added from the remote. The same comparison, the same, that this line is deleted and these two lines, one blank line and one additional line has been added, but this is now compared to the remote. I can also go ahead and compare the two files. So let's create another file, atest.txt, or let's rename it to new test.txt, and let's add. This is added from remote. Sorry, not remote. Let's make it from local. Now I can use git diff to compare these two files. Not git diff, I can directly use the diff command, test.txt and new test.txt. So I can clearly see that I have these changes. This is my line 1, this is my file 1 which is test.txt, and this is my file 2 which is new test.txt, and the changes are differentiated from this line dash dash. If I copy test.txt now to new test.txt, then these are identical. But if I go ahead and just edit a single word, then you see this line is coming as the difference. So there is F missing, but this complete line will be treated as a different line. We can also go ahead and compare the two commits. So we check these options, we compare two files. Now we can compare two commits as well. And how do we do that? Commits can be identified with the commit ID. So if I do git log, I'll have the commit ID. Now I can compare them. So let's do git diff. Let's copy these. So I'm gonna copy two different commit IDs. And if I do this, then it is saying me that there were two files, test.txt and test.txt, and this line has been removed. If I look at their comments, then this is 965, which is updated text file. Now let's compare these two. Let's compare the latest one and this one. So this line is not there in the first file, which is test.txt, which is the latest commit. This is added from local repository, is not there in the other file. We can also go ahead and compare file with any commit. So how can I do it? You can, again, let's look at the log and then compare with, let's copy this. What I did is I compared this commit ID with the workspace file. Now there are other options as well that we can compare with any two files on the disk, which we already saw. We can compare two commits, we can compare any file with any commit. Now to compare local branch with the remote, we already saw how this can happen, that someone else might have contributed in his copy and then pushed that changes to the remote while we have not pulled the changes yet. So first what we have to do, we have to update our remote tracking branches. How do we do that? We do git fetch and the remote branch name. Now remote branch name is origin, for example, which is the default one. Next, what I can do is I can do git diff master branch and the remote branch path. What is the remote branch path? How does it different from the master? So if I do git branch, master is my master branch path, while remote branch path will become origin / master, the remote branch name / the remote repository name / the branch name. Let's go back to this again. Let's open some file, let's edit it and then do a git fetch. So what I'm gonna do is I'm going to add compare remote. Let's remove this. Let's commit this file for compare. Now what I'm going to do is I'm going to fetch this changes to the repository. Git fetch origin, the repository name. So what is it? We update the remote tracking branches. So this is my remote tracking branch and this is my master branch. Next, what I'll do is I'll do a quick diff, git diff master and then origin master. What we saw is we have compared the master branch with the remote master branch, right? Origin slash master. So what we did is we first fetched the remote tracking branch and then we compared them. Now this command will list all the branches. So you can see that master, new branch, new tab, and then it is also showing the remote branches. So we can choose the branch name from there. For example, this option that we already saw, masters origin slash master, where master is the local master branch and origin slash master is a remote namely origin and master branch. So origin is the remote repository name and master is the branch name. So fork is the another command that we have in the GitHub. So what happens is that it allows us to copy other repositories for our own use. So we can experiment with the changes or we can go ahead and start the development from that branch. So this is like a very popular and the useful feature of GitHub mainly. So it acts as the bridge between original repository and the personal copy. By personal copy, we mean that we can copy the data, the complete metadata in the repository, and then we can start working on it. The only thing we won't get are the settings. So this is core of the social coding, which is called as open source at GitHub. So folks are used to suggest changes or to use someone else's project as a beginning point for your own. For example, if someone has done, this is very popular when you come to blogging. For example, if you're using some theme or some blogs, or maybe you're building some analytics project of your own and someone has already contributed to the GitHub, then you can fork that repository and then you can start contributing in it. Of course, you will have to check the license if you're building that product for or developing that code for the remote for the production use. Then you will have to check the license and then you can start contributing. So the best example of using forks is for bug fixes, where you fork the repository for fix issues and raise pull requests to merge in with the original branch. So it is a two-step process. One, on GitHub we go to the repository and click on the fork button. After fork, to work on local repository, you can either clone it or download it. For example, so what I'm gonna do is I'm gonna go to some username, for example, and I'm gonna go to, let's say, the bit start, not the bit starter. I'm gonna go to this credit card analyzer and I'm gonna fork this repository for my use. So if I fork it, so now this repository is available for my use, right? I can now use this as a starting point for my project, and to use this I have to clone it again. So if you see the Git, the repository name has my username, the repository URL has my username. So I go ahead and I clone it. So I have this repository at my this local workspace for my use. So I can add anything and then push it. For example, let's add this file. This line should be treated as dummy. I add this and I commit this. Added dummy line. And now I push it. So let me check the first branch. Git and the remote. Git push origin and then master. Then it will ask for my credentials. So if I go here and check the history, then I have this dummy line available. But if I go there for the place where it is forked from, then you can clearly see that the change does not exist there. So I have this copy of the project as my repository. Git is a largely distributed, which means there is no inherent concept of upstream and downstream. It depends on the way data flows. For example, the other repo will be upstream even when data is pushed onto it. And if I'm pulling from the other repo, then other repository is upstream and my repository is downstream. For example, the in credit card analyzer project, the repository of this user is upstream while my copy is downstream. This is relative between the two repositories. So to sync changes which are in the original repository which we have forked we configure a remote that points to the upstream repository, and to do it we have to do what? We have to just use this command git remote add upstream and the repository name. So if I do git remote -v, let me first copy the repository URL, and if I go here and if I do, then I have to add this. I have added the upstream. If I again do the remote -v, then you can see I can see the upstream URLs for both fetch and the remote, which contains the original owner of the repository. I can also do this sync. So instead I can use the upstream repository name, and then I can check out the forks local branch. So this is the fork, means the downstream repository. So this is similar to other. This will work like any other repository on my local. If I do git branch, then I can see there's only one branch, but the remote are different. We can also consider merging it. So instead of using origin, I can use upstream. We are already up to date. I can also do the git diff, or let's say not the diff, but the difference is that this line should be treated as dummy, does not exist in the upstream. It is only in my remote repository. So this is the change that I can see. Why it is only showing my branches upstream. So I cannot go ahead and make changes in the upstream because I don't have the ownership. I can suggest changes and then it will be up to the approval of it. However, if something has been changed in the upstream, then what I can do is I can merge it with my local repository, which will be similar to pull. So it will pull the data onto my local repository and I can work on it. So now coming to pull. Pull is the very useful command. We have been using it. So this is like opposite of push. In push, we are pushing from local repository to the remote, while in pull, we are downloading the data from remote to the local. So that downloaded data has been pushed by some other user for some other commit or from other feature. Might be they have added some feature, or they have added some bug fix, or they have changed something. So we are downloading, we are updating our repository on our local. So this is the source repository, and we have feature source as the branch name. We do a pull request, and then this is our destination repository, and this is the master destination repository. This is the branch name, the master branch name. So how it will work is that if someone has added something in the destination repository, then I can pull it onto my local repository. So this is commonly used by, this is a very general command in the Git, which is commonly used by teams and organizations which have more than one contributor. So developers work on their feature branch and raise a pull request to merge to shared repository. What it means is that we can have multiple branches and then we can have a pull request created. Open source projects usually pull requests to manage changes from different contributors, because open source projects have many contributors who are contributing to them. So they use pull requests to manage the changes. Now, how do we create a pull request? Now, after we have made changes to the fork, after we have forked the project, we create a pull request to ask us to upstream request repository to merge our changes. We are not committing them directly. The word here to note is the ask. So below the steps, we confirm the repository we want to change. We select the branch of the upstream repository to merge, and we use the base branch from the drop down menu. Once we selected the base drop down menu, we select your fork using the head fork drop down menu, which is this, and then we select the branch we want to make changes from compare branch drop down menu. So let's take this example. So let's push, we already have pushed something, right? So what I'm going to do is I'm to create a pull request. Before I go here, let's read what it's saying. So pull requests help you collaborate on code with other people. As pull requests are created, they will appear here in searchable and filterable list. To get started, we should create a pull request. So let's create one. This is our base branch. Base branch is the original branch. This is our head fork. So the base branch name is master. Again, we have only one branch and the master. Now we can see the comparison. We have added one line and there is no change as such. This commits has been made by Edureka Global, which has added a dummy line. These are the comments, and this is done on December 3rd, 2018. So we have one change file with two addition. One is the blank line and second is the line we added. I can also see the split view, right? This is the split view. This is the base copy and this is our working copy, the Edureka GitHub. So let's create a pull request. So now we have added a dummy line, and it says it is not merged, but it says it wants to merge one commit into Ayushiri master from Edureka GitHub master branch. This branch has no conflict with the base branch. Now if I go here, then we won't be seeing this because till the time someone approves it. Now this is the pull request we are seeing. Before we do that, let's see if this has been added in the readme.md, which we are seeing here. We won't be seeing here because this has not been approved, but we can go to pull request and we can see it here. So let's try to open this as a public user. So we are getting the whole history. We are saying that this is the commit and this is the file changed. So we can clearly see once someone approves it, then this change will actually appear in the original repository, which is here. So this is how they manage with open source projects which have millions of developers. They fork it, they work on their own, and then they create a pull request. So we are providing title and description, and then we can also control the access, which is appearing at the bottom, which allows for edits from maintainers. So someone else might change your pull request, make a small change here and there. We click on pull request and it will be available.
Now, the continuous methodologies of software development are based on automating the execution of scripts to minimize the chance of introducing errors while developing applications. They require less human intervention or even no intervention at all from the development of new code until its deployment. It involves continuous building and deploying code changes at every small iteration, reducing the chance of deploying new code based on budget or failed previous versions. There are three main approaches to this methodology, each of them to be applied according to what best your strategy. Continuous integration. Consider multiple developers working on an app. This application has its code stored in each of their respective local repositories. But ultimately, there has to be one code, isn't it? Therefore, all the involved developers push their code changes to a common remote repository to the code. This happens every day, multiple times a day till the code is complete. This practice is known as continuous integration. For every change submitted to an application, it's built and tested automatically and continuously, ensuring the introduced changes pass all tests, guidelines, and code compliance standards you established for your app, eventually decreasing the chance of introducing errors in your application. Continuous delivery. This is a step beyond continuous integration. Your application is not only built and tested at every code change pushed to the code base, but as an additional step, it is also deployed continuously, though the deployments are triggered manually. This method ensures that the code is checked automatically, but requires human intervention to manually and strategically trigger the deployment of the changes. Continuous deployment. This is also a step beyond continuous integration, similar to continuous delivery. The difference is that instead of deploying your application manually, you set it to be deployed automatically. This does not require human intervention at all to have your application deployed. If we take a deeper look into the basic workflow, we can see each stage of DevOps lifecycle. So you basically verify, package, and release your application using the CI/CD pipeline. This has quite a few advantages in the deployment and production environment, including, but not limited to, increased speed of operation, communication between teams, regular feedback due to frequent deployment cycles, easier detection of errors resulting in early recovery. Now that we have some idea about CI/CD, let's dive a little deeper into the element which makes it all possible: pipelines. So what are pipelines? Pipelines are basically the fundamental building blocks of CI/CD and are hence the backbone of modern DevOps environment. A CI/CD pipeline bridges the gap between development and operations team by automating the building, testing, and deployment of applications. It basically helps to automate a series of steps or stages in your software development process, such as initiating code builds, running tests, deploying, and staging production environments, and everything in between. It provides a more standardized approach to feedback loops, reducing errors, and paces up iterations of development. Now, there are different stages in pipeline implementation, which lays a strong foundation for the continuous everything we all so desperately seek to achieve. At number 1 is commit. In this stage, new codes are integrated to the base code. You have a feedback loop to help check the code quality and a series of unit tests and sanity tests for the same. This is not to be mistaken with the testing stage that comes later in the pipeline implementation. Next up is build. Once the code is tested and integrated, in the next stage, the code is built. This is where the source code is converted into an executable form that can be run on a machine. The testing stage. In the testing stage, the alpha and beta deployments take place. The former checks the integration between various builds at hand, while the latter to check if the app is working before moving it to production. The deployment stage. Once the build has gone through all the test scenarios successfully, it is ready to be deployed to the production stage. You then finally move to the fourth and final stage and deploy your application, and your app goes live for the end user environment, that is your consumers. Now, there are a couple of tools popular for being able to automate this entire process. Two big names you'd often hear are Jenkins and GitLab CI/CD. To know more about Jenkins, you can check out the extensive Jenkins playlist on our channel. But today, we are going to tackle the big name that is GitLab CI/CD. GitLab CI/CD is a powerful tool into GitLab that allows you to apply all the continuous methods, that is continuous integration, continuous delivery, and continuous deployment to your software with no third-party application or integration needed. To use GitLab CI/CD, all you need is an application code base hosted in a Git repository, and for your build, test, and deployment scripts to be specified in a file called GitLab CI.yml located in the root path of your repository. In this file, you can define scripts you want to run, define include and cache dependencies, choose commands that you want to run in sequence and those you want to run in parallel, define where you want to deploy your application, and specify whether you want to run your scripts automatically or trigger any of them manually. Once you're familiar with GitLab CI/CD, you can add more steps in the configuration file. To add scripts to the file, you'll need to organize them in a sequence that suits your application and are in accordance with the tests you wish to perform. To visualize this process, imagine that all the scripts you add to the configuration file are same as the commands that you run on the terminal on your computer. So here is an example of the simplest pipeline configuration that can be using a minimal Docker image based on Alpine Linux. You have two builds. Build A, build something, and build B, build something else. This pipeline will run everything in build stage concurrently, and once all of those finish, it will run everything in the test stage the same way and then deploy A and B. Now, this pipeline needs to be configured using a YAML file called as the GitLab CI/CD.yml within each project. The GitLab CI.yml file defines the structure and order of the pipelines and determines what to execute and what decisions to make when specific conditions are encountered. Say, for example, when a process succeeds or fails. Here's the YAML file for the same pipeline diagram we saw before. You can see all the different stages in the pipeline, that is build, test, and deploy. And each stage has a script to be printed to depict what's going on in that particular stage. Fairly simple, isn't it? Now, know that it's a very rudimentary pipeline and definitely not the most efficient. And if you have lots of steps, it can grow quite complex, but it's easy to maintain. There are other pipelines for that, such as direct acyclic graphs and parent-child pipelines. But since we are just starting out, a basic pipeline is what we're going to understand and implement later on in this session. Once you've added the configuration file, which is the YAML file, to your repository, GitLab will detect it and run your scripts with the tool called GitLab Runner, which works similar to your terminal. The scripts are grouped into jobs, and together they compose a pipeline. It is designed to run on GNU Linux, Mac OS, and Windows operating systems. GitLab CI/CD not only executes the jobs that you've set, but also shows you what exactly happens during the execution, just as you would see in your terminal. You create the strategy for your application, and GitLab runs the pipeline for you according to what you've defined. Your pipeline status is also displayed by GitLab. At the end, if anything goes wrong, you can easily roll back all the changes. Consider the following example for how GitLab CI/CD fits in a common deployment workflow. Assume that you have discussed a code implementation in an issue and worked locally on your proposed changes. Once you push your commits to a future branch in a remote repository in GitLab, the CI/CD pipeline set for your project is triggered. By doing so, GitLab CI/CD runs automated scripts that can be sequential or parallel to build and test your application and preview the changes per merge request. Once you're happy with your implementation, you can get your code reviewed and approved, merge the feature branch into the default branch. GitLab CI/CD deploys your changes automatically to a production environment. And finally, you and your team can easily roll back if something goes wrong. GitLab CI/CD is capable of doing a lot more. Now that you know about GitLab CI/CD, let's install and set up what we need to be able to run our pipeline. So first things first, let's install GitLab. I'm running Ubuntu 19 on my virtual machine. So let's open the terminal. First, we need to install a few packages to install the GitLab, and those are the OpenSSH server and postfix mail server, which can be installed using the following command. You have to configure the internet and set the system mail as follows. Here, you have to set the system mail. The required packages have now been installed. In the next step, we have to install GitLab, and there are various methods to install it. We can download a Debian package directly onto our systems. So in order to download that, you need to go to the official site and get the link directly based on your distribution. So now let's just copy and paste it onto our terminal and hit enter. After executing this command, you'll have to navigate to the directory where it's stored and then install it. As you can see, the Debian package is available and you can install it using the following command. Now this might take about 5 minutes based on your system configuration, and for installing it, you need 4 GB of RAM at least. So GitLab is partially installed. As you can see here, it's unable to detect a valid host name for your instance. For this, you have to convert a URL. We're going to edit this file now and add your host name. So after adding your host name, just save and quit the file. Now you can start your GitLab instance by running the following command. So as you can see over here, the GitLab instance has been configured in this machine, and you can now access it from the browser. Go to gitlab.com and create an account. I've already created mine. To do that, all you have to do is fill in some information in the given fields. It contains nothing but your name, email, and a password. Check the first box, which is the Terms and Conditions Acceptance checkbox, and also confirm that you're not a robot by any means. Click on the green register button and you're done. This will send a confirmation mail to your email ID. Open it and confirm your GitLab sign up. You can then sign in with your email and password to GitLab. So here is what mine looks like. So once you're logged into your account, you should see something like this. Click on the New Project button over here. So we are going to create a very simple project the one from earlier just to demonstrate the basic functionality of GitLab. So go ahead and click on New Project and populate this field with something. I'll type Edureka pipeline, and right here below, you have the possibility of selecting the visibility. You can make it public if you want, but I will leave it private because I'm just playing around. So go ahead and create the project. Once you're ready, you will have an empty repository like this. There's nothing inside it, so the first thing that we're going to do is create a new file. The file will be called master/.gitlab-ci.yml. This is how the file should be named, and this is the convention it will automatically recognize. So I'll paste my pipeline code inside here. And what we're trying to do here is to create 3 basic stages. There is a build stage, a test stage, and a deploy stage. In order to get something to run, you need to define some steps in each of these stages. This is just to demonstrate that you can enter multiple commands one after another in a stage. So now we have this file. Let's commit and see if the syntax that we have over here is valid. Now we're getting this message over here that says GitLab configuration is valid. Congrats. Now if you go to the project overview, you will see here that something has started to build. This is the icon that shows the pipeline has started, and I did not need to configure anything in particular. Just by having this file here and no other files, GitLab started building this pipeline as instructed. And if I click on this icon, I'll actually be able to see the pipeline, how it looks within the 3 stages. Now this will take a minute to start a Docker image and to actually execute it. The first stage succeeded. This goes down to the second stage. Now you will see that the second stage is running as well. Now let's see if the pipeline is successful. You can easily see the pipelines that are currently running if you go on over here on the left panel and click on CI/CD pipelines. You can see that the current pipeline is running the stage it's in and how much it still needs to be in order to complete. Now I just refreshed the page and we see that it has run all the stages successfully.
So what is branching? Nearly every VCS has some form of branching support. Branching means you diverge from the main line of development and contribute to do work without messing with that main line. In many VCS tools, this is a somewhat expensive process, often requiring you to create a new copy of your source code directory, which can take a long time for large projects. Some people refer to Git's branching model as its killer feature, and it certainly sets Git apart in the VCS community. The way Git branches is incredibly lightweight, making branching operations nearly instantaneous and switching back and forth between branches generally just as fast. Unlike many other VCS, Git encourages workflows that branch and merge, often even multiple times in a day. Understanding and mastering these features gives you a powerful and unique tool, and it can entirely change the way that you develop. So another main difference is that developers can create their own branches and can work in parallel. This keeps the main master branch free from the questionable codes. For example, if this one is the master branch, then you can have 2 more branches working in parallel. One can be the feature and another can be the bug fix. One of the biggest advantages of Git is its branching capabilities. Unlike centralized version control system, Git branches are cheap and easy to merge. This facilitates the feature branch workflow, which is popular with many Git users. The feature branches provide an isolated environment for every change to your code base. And when a developer wants to start working on something, no matter how big or small, they create a new branch. This ensures that the master branch always contains production quality code. Using feature branches is not only more reliable than directly editing production code, but it also provides organizational benefits. So in this example, we have a master branch, and then in between we created a test branch and later on created a feature branch. Because branches are lightweight and they are very fast switching back and forth. So Git branch is essentially an independent line of development. You can take advantage of branching when working on new features or bug fixes because it isolates your work from that of other team members. Branches serve as an abstraction for the edit stage or commit process. You can think of them as a way to request a brand new working directory, staging area, and project history. When you want to add a new feature or fix a bug, no matter how big or how small, you spawn a new branch to encapsulate your changes. This makes it harder for unstable code to get merged into the main code base and gives you the chance to clean up your features history before merging it into the main branch. The default branch name is master. This is created by git init command on the repository. Movable pointer to a snapshot of your changes, and it moves with the changes you commit. So these are the branches operations. We can create a new branch, or we can create and switch to the new branch directly. To create a new branch, we have to use git branch and the branch name. And to create and switch the new branch with a single command, we can use git checkout -b and the new branch name. So let's try this. If I'm in module 3 and if I check git branch, then I have 3 branches: new branch, new temp, and temp. If I create another branch, bug fix, now let's create test. Let's take to bug fix. Then I'm still on master branch. To use the bug fix, I have to choose git checkout bug fix. Now there is a simple way to create and switch to the branch at the same time, and the command is so now what happened is we replaced 2 commands with the 1. So command git branch name and the second command git checkout branch name is replaced with git checkout -b branch name. To list branches for a particular repository or to locate repository and click on the branches as highlighted. So we already saw this, but let's go back there again. Let's choose any repository. Let's take the module 3 only. We click on the branch here and then you can see all the branches. We have 2 branches: remote branches, master, and new branch. We can also check that using -a option. So we have 2 remote branches, master and new branch, and 4 local branches. Let's discuss the Git storage strategy. So Git does not store data as a series of chain sets or differences, but instead as a series of snapshots. When you make a commit, Git stores a commit object that contains pointer to the snapshot of the content use stage. This object also contains the author's name and email address, the message that you typed, and pointers to the commit or commits that directly came from the commit, its parent or parents. 0 parents for the initial commit, 1 parent for normal commit, and multiple parents for commit that results from a merge of 2 or more branches. To visualize this, let's assume that you have a directory containing 3 files and you stage them all and commit. Staging the files usually compute a checksum for each one. It stores that version of file in the Git repository and adds that checksum to the staging area. So after staging, 2 things are happening. Git computes the checksum and stores each version of each file and adds to the staging area. When you create the commit by running the git commit, git checksum each subdirectory, in this case just the root project directory, and store those 3 objects in the Git repository. Git then creates a commit object that has the metadata and a pointer to the root project tree, so it can recreate the snapshot when needed. Now Git places only 4 types of objects in the object store: the blobs, trees, commits, and tags. We already discussed them in the past module. Now these 4 atomic objects form the foundation of Git's higher level data structures. First, the blobs. Each version of file is represented as a blob. Blob, which is a contradiction of binary large object, is a term that is commonly used in computing to refer to some variable or file that can contain any data and whose internal structure is ignored by the program. For each file, there is one blob, which stores the SHA-1 hash of the file content in it. Next come the trees, which represents one level of directory information, that is, a hierarchical structure which contains information about each of the blob. It creates relationship between directories and the files in it. Next is the commit. The commit object holds the metadata for each change introduced into the repository, including the author, committer, commit date, and the log message. Each commit points to a tree object with all metadata. Next are the tags. So we have not discussed tagging so far, but tagging is generally used to capture a point in history that is used for a marked version release, such as v1.0.1. A tag is like a branch. that does not change. Unlike branches, tags after being created have no further history of commits. Now Git supports two types of tags, annotated and the lightweight tags, which differ in the amount of accompanying metadata they store. A best practice is to consider annotated tags as public and lightweight tags as private. Annotated tags store extra metadata such as tracker name, email, and date. This is important data for a public release. Lightweight tags are essentially bookmarks to a commit. They are just a name and a pointer to a commit, which is useful for creating quick links to relevant commits. Now this is the storage strategy for object structure. Now if you see, we have at the first level we have blocks where each file is represented as a blob. Next we have tree, which contains content of directories and specifies files stored as blobs. So we have a tree, which tree name, we have a blob, the hash, and the file name. And then we have commit, which is a pointer containing the metadata and pointer to root tree. So this is the commit ID. Then we have tree, which is tree ID. Then we have author Steve, committer Steve, and the parent JB007. Now on creating a new commit, the new commit will store a pointer to the commit preceding it. For example, this. So this is JB007 and the parent of this commit is this. Now the parent of this commit is this. So this is snapshot A, B, and C. Now how Git internally manage these branches. Let's say you created a new branch testing using below command, git branch testing. This will create a new pointer to previous commit. The previous commit is this, 0BI-Y2. Now Git also keeps an additional pointer which is called as head. So head will always point to the last commit of the branch. For example, if the branch we are on branch master, then head will point to this. Now if we check out a new branch testing, then head will move to the last commit of the test branch. And when we make additional commits in the test branch, the head will move forward, or the pointer will move forward. So there are two types of branches, local branch and a remote branch. Local branch is a branch that only you, that is the local user, can see. It exists only on your local machine. And the command to create is git branch and your branch name. While the remote branch is a branch on a remote location, in most cases, or the default remote name is origin, you can push the newly created local branch to origin. Now other users can track it and can see it. So the default name from local branch that gets created when you run git init is known as master, which is traditionally it is also known as trunk. So let's quickly do a demo here. Let's go to temp. Let's remove temp and let's go to temp. Oh, mkdir temp. I'm gonna do now git init into it. Now wait, let me first remove it. Now I'm gonna create a file into it. Touch file.txt. Now let's initialize git branch coming. There's some issue with my configuration. Ideally it will show the branch, but if I do git status, I should get I'm on branch master. So this is the default branch I'm getting. Now I can create additional branches such as dev, feature, and bug. These all constitute of branches created for the developer so that they can work parallelly and independently on individual tasks without any interference. Now certain conventions are provided as best practices. For example, feature branch can be named as feature, bug branch as bug, release branch as release. A remote branch, on the other hand, is a local copy, or the remote tracking branch I should say is a local copy of a remote branch. When a branch is pushed to a origin using the command, a remote tracking branch named origin/branch name is created on your machine. This remote tracking branch tracks the remote branch. You can update this remote tracking branch to be in sync with the remote branch using git fetch or git pull. Now let me show you what does the remote tracking branch mean. If I go to module 3, so now this origin/master is my remote branch. I don't have a remote feature branch. Feature is only a local branch. If you see here, this is just a local branch. However, this is a remote branch which has a remote tracking branch origin master. Now let's see the branches example. So when a git clone command is executed, how do we execute the git clone? We just copy the remote URL, or we get the remote repository URL, and then we execute the command git clone. Now when we do git clone, then Git will pull all data from the remote repository to my local, which is remote repository to the local. Now Git automatically names the clone repository to origin. This is the default. And a pointer is created at the master branch, which is known as origin/master. A local master, which is this, is also created at the same position for local operations. Now switching between branches and different commits. To switch to a particular branch, we already know how to clone it, but before we move any further, let's clone it again. So I'm going to remove the module 3. Let's leave the module 3 as it is. Okay, I'm going to leave the module 3 and I'm going to clone it again. So I'm going to move into the module and let's look at the branch. We have one branch and the one remote tracking branch. So to create a branch, what I can do is I can do get checkout bug, not the checkout, sorry. To switch between a branch, we have to use git checkout branch, but before that, let's create a branch. I can use bug now, and if I do create branch, then I am on branch bug. Now I have created a bug branch. Now there are few other options I can create a branch. So the first one is I can create local branch from the head and can switch to it automatically. So instead of creating git branch, I can use git checkout -b, let's call it feature. So I have created a new branch and I have switched to it as well. So in general, git branch name, and command, or I should say yes, and command git checkout your branch name is equivalent to git checkout -b branch name. Now another one is we can create a new branch from the commit hash. So let's look at the commit hash. Now this is the commit hash, so I can use a new branch. And so if I do git branch, I can see that I have a commit hash. If I do git log, then I can see that this branch is the commit hash branch is created from this commit ID. I can also create a branch from 4, for example, for 4 head prior to commit. So the command is same. So if I do git checkout -b, my branch name, head prior, and then I do head 4. So this will be like, this is the head, then it will go like, first of all, let me go to master. And if I do git log, then I can see that I was on master only. So let's create another -b new branch. Let's call it head prior and head root 4. So ideally, if I do root 4, then this is like head 1, 2, 3, 4. This should be somewhere around here. So it's switched. So git log. Now if I do git log, then this is the 4th. 1, 2, 3, 4, and this one, as I said. These are all different ways of creating a branch and switching between them. So to switch to a particular commit, we need to use commit hash, and commit hash is this. For example, if I want to switch to this one, I can use git checkout and then the hash. But when we do this, our head will go in a detached state. So we can look around, make experiment, and we can create a new branch using -b. For example, give checkout -b and detached. If I do git branch now, you can see this is there. I can do git log and first checkout master. And if I do now git log, I can see that detached is from this commit ID. So commit hash is a generated SHA-1 hash for a particular commit and can't be changed until the user changes the commit details. Now we can also delete a branch. This might become handy. So for example, there might be change scenarios when we spin a new branch, for example, feature, we merge it back onto the master so that it goes into production. So feature branch now, for example, has no use and can be discarded as it is already merged in the master. So the way to do it is use the -d option or -D, which is equal to force option. So if there is unmerged branches, we use -d. If the merged branches, we use small d. So let's get branch. First of all, see the branches. Then, and I do get branch -d bug. If I do git branch now, this is deleted. Now the point here to note is that this has only deleted the local branch. This has all not deleted the branches into the repository, which is the remote branch. So how do we delete the remote branch? If I do git -a branch -a, we see both the branches. So we have only one branch so far. So let's push one branch on, let's push the bug feature branch on the remote. This will ask for my credentials. So now how can I delete this branch? So I can do like, to delete a branch, I can do git push -d, the remote name and the branch name. Here remote name is origin and the branch name is feature. This will again ask for credentials. I strongly suggest you to use the passwordless SSH setup in the Git. Now the remote branches Git is been removed, but only removed. And now if you will see, the feature still exists because this is on the local branch. Another way to remove that is using git push the remote name colon the branch name. For example, let's push the feature again. We are deleting it, we're not pushing it. So let's remove the -d and let's push the feature again. To remove it, I can only do add colon here, but before that let's first look at the branches. So I have a feature branch, and to delete it I just add colon before and it will delete the branch for me. Next comes the merge conflicts. So for a lot of people, merge conflicts are as scary as accidentally formatting the hard drive. A great thing about having Git as your version control system is that it makes merging extremely easy. And in most cases, Git will figure out how to integrate new changes. However, there are a handful of situations where you might have to step in and tell Git what to do. Most notably, this is when changing the same file. Even in this case, Git will most likely be able to figure out on its own, but if two people change the same lines at the same file, or if one person decided to delete it while other person decided to modify it, Git simply cannot know what is correct. Git will then mark the file as having a conflict which you will have to solve before you can continue your work. So in this example, we have this file and these both are modifying the same file and the same line, the third line. So this will create a merge conflict. So merge conflicts can occur on merging branches or when merging forged history together. So merge conflicts are resolved manually by users. Git provides different merge tools to compare and choose the required changes, which we will see in the coming slide, or user can use the third party merge tool with Git. So let's look at the example that this is a file and in the master branch, and we add some line in the master branch again. From the base branch, we create a new branch called feature1 and we add another change in it. So what happens is that when we merge these branch with the master, then we'll get a merge conflict. So let's first create this example. So I'm gonna go again, and now if I look at the branches, now let me remove the old branches which might confuse us, and the head prior as well. Right, if I do the git branch, then I have feature and master. Let's also remove the feature branch. So git branch -d feature. Now let's edit the test.txt and let's remove it from base branch. Now let's add it to the staging area and commit it. Now let's create a new branch, feature1. Now let's rename it features plain. Now let's edit the test. We are still on the master branch, so I'm gonna use right from master branch. Now same I'll do again. I'll add it and then I'll commit it with comment as master. Now let's check out to switch to the feature branch, change the same file, and let's write from feature branch. Do the same things, add it to stage area and commit it. Now let's go back, switch to the master branch again. Now we already see that there is some point of conflict that will arrive, but let's merge it, the feature branch to master. Now here we get a merge conflict, right? It says that we have a conflict in test.txt and we have to fix it, and then we can commit. So there are many ways available, but the one quick way will be that we use some tool. So what we're going to do, we are introduce some tool which is using kdiff3, and the command is git config. We said we already discussed git configs in the past module as well. So if you have any issues in them, or if you are not sure what they are, I request you to go back to the previous module and just brush this up. So we are setting a global config where I'm defining merge tool as kdiff3. Now once that is done, we just run this command git merge tool, and this will open us file, and then we can select which merge we want to see and which not. So here what we get is, we get the total number of conflicts 1, number of automatic to solve conflicts 0, number of unsolved conflicts 1. So we have the base branch, we have the local branch and the remote branch. Remote branch is feature, local is master since we are on master, and the base is the parent branch. Now we saw the base version. This column as displayed here represent the changes which will be made in this area. So we can go to the click on the letters, and then it will enable us to see what we want to keep. For example, if I click on B, if I click on A, then no source line. If I click on B, because there is no source line in the master, hence we're getting this. We are not updated, we added a line. If I click on B, then I get from master branch. If I get C, then I get both. If I remove B, then I can keep only feature. So let's keep the both, and let's save this file, right? Now once that is done, I can open my test.txt and look at this. I can now commit it again. Let's look at the Git status. I can commit it. Also have a look at this file. So this is how it will resolve the conflict in case there is no tool we are using. So this line has no conflict from base branch, hence it is above. Then we have conflicts in the second line. So where what he is saying there, that for the branch head branch which is pointing to master, this is the line from master, and then we have the separator line, and then we have the line from the feature branch which we are trying to merge from feature branch. So we can do it manually. How? We can delete these lines, and I can decide that I want to keep them both, so I just do keep them both. So let's now discuss about stashing. First of all, let's look at the requirements that why stashing came into picture. So often when you have been working on part of your projects, things might be in a messy state, and you might want to switch branches for a bit to work on something else. The problem is you don't want to do a commit of half done work just so you can get back to this point later. The answer to this issue is the git stash command. Stashing takes the dirty state of your working directory, that is your modified untracked files and stash changes, and saves it on a stack of unfinished changes that you can reapply at any time. Please note, it does not consider the untracked files. Stash the changes in dirty working directory. By dirty we mean the work that is not completed yet and is in progress. Stashing command only takes the uncommitted changes. They might be in the staged area or they might be in the unstaged area, but they are track files. So stash command flow is, it records the current state of working directory and index. It saves local uncommitted changes separately and reverts the working directory to head commit. After this, you will get a clean branch. Once that is done, you can reapply the stash changes again when you come to that branch using stash pop or stash apply command. And in case you don't want to apply any stash changes further, you can just clear the stash. So these are the changes for stash. For stash to local changes, by local we mean the local branch, we use the git stash command. To list the modifications stashed away by this command, we can use the git stash list. And to inspect or check the details, we use git show stash. So let's look at this. So we are going to continue using the module 3 project. So let's do git status. So we have this untracked file, and now I'm going to change the test.txt. Now I'm going to remove all this and say this is for stashing demo. Now if I do git status, I can see that test.txt is modified. At the same time, let's also change some of the file. Let's change the readme.md. This is for stashing. I'm gonna put this readme.md to the staging area now. So if I look the status, we have one in the staging area, one is in unstaged area, and the last one is in untracked file. If I look at the Git branch, so I have feature branch and master branch, and we are currently on feature. If we, for example, let's first try to check out the feature branch. There's a typo in my command. So it is not allowing me to do a checkout of feature branch. Why? Because I have changes in the staging area, and it is asking me to commit my changes or stash them before I switch the branch. So if I look at the branches again, maybe I'm still on master, and now I'm going to do git stash. So I can now go ahead and change the branch, and if I look the git status, then I only see the untracked files, while the files which were in unstaged area or which were in the staged area are not present. Let me revert back to the master branch. Now let's list the stash changes. We have one stash, which is this. Let's also show the changes in it. So here is that we have a commit ID. This is the commit ID and the merge, the author name, date, and some other comments. And now I can see the changes. So I have two files. One is the test.txt, when I have removed these three files. And if I do the status, then let me pop git dash pop. So I have two modified files, readme.md. Now the point here is that the files which are in the staged area, for example, readme.md was in staged area, they now have been moved to the unstaged area when I do stash. So this is the git status. Now I can apply them directly. Now I have to do git stash. First of all, let's look at the list. No. So let's stash this again. And now let's do git stash apply. So once I do apply, I get the same thing. If I do the git status now this is the demo that we just saw. Now at the same time, I can use the git stash clear command as well. So let's look at the different options that we have in the git stash. So we have list, show, drop, pop, apply, branch, clear, create, store. We can use these different options. For example, list that we currently saw, we also looked at the show, pop, apply. I can create a branch as well, starting from the commit at which the stash was originally created. I can remove all the stash entries using clear. I can remove a single stash entry from the list of stash entry. I can create a stash entry, and I can store the stash created via git stash create. These are some examples as well, so you can check them in your workspace. So what we're doing here is, if we do the git status, we can see that we have two files in the unstaged area, the readme.md and the pom.xml. After stashing the changes, no changes are left in the branch, and git status command shows that the branch is up to date. Now what we did is, if we do the list, then we already saw this. When we did the git show, then we see the difference. There is readme.md and there is pom.xml. Same as the case that we saw. If we go back here, right, so we have test.txt. I don't know why we are not seeing the readme.md. Maybe that was because it was in the unstaged area. But if I do the git status now, and if I remove this test.txt.orig, and if I do git stash now, then let's do the git status. So it is up to date. If I do git stash show stash, then now I see the readme.md. It was not displaying the readme.md because it was in the staged area and moved to the unstaged one. We can apply the git stash using git stash apply. But if we look at the status so far, it is up to date. But if I do git stash apply, then we have moved these files in the unstaged area. We can also use the git pop, the same that we already saw.
So now let us take a look at the Git Basic Commands. So if you want to create repositories, let's say you want to create your local repository, you just have to initialize it using git init. Or if there is an existing repository, you can use git clone. If you want to make changes in your file, you can use different commands. You can use git status to see whether a file is there in your index or not. You can use git add in order to add a file on your index, and you can finally use git commit in order to commit those changes that you have made. For syncing in repositories, so you know that in Git we deal with two repositories, the central and a local. So you have to inform your local repository that which is your central repository that basically lies on a remote machine. So for that, we add origin. We add the link of the central repository using this command, git remote add origin. And then if you want to pull all the files that are in the existing central repository, you use a git pull. And then finally, if you want to reflect your changes into the central repository, you can use git push. For parallel development, we have got Git branch. It allows you to branch off from your main branch and you can work on different features on a completely isolated branch using Git branch. And then you can finally also merge all those changes in your production deployable branch, which is usually the master branch, using Git merge. And then we can also use Git Rebase. Now this is a special kind of merge. So it basically does the same thing as Git merge, only the commit workflow or the commit working tree looks a little bit different. So you'll know about that because we'll be using Rebase in today's session. So now let us take a look at the Git workflows. So basically the Git workflows can be categorized into broadly 3 kinds. So there is the centralized workflow where there is one central repository and only one working branch, which is the master branch. Then there is the feature branch workflow where you have dedicated branches for each feature. And then you've got Git Flow. So we'll take a look at all of this and how to solve conflicts in each of these workflows. So now let us talk about the centralized workflow. So the centralized workflow uses a central repository to serve as a single point of entry for all changes to the project. And there is only one default development branch and it is called the master, and all changes are committed into this branch. So this workflow does not require any branches besides the master. So what the developers do, they start by cloning the central repository into their local repository. And in their own local copies of the project, they will edit the files, commit changes, but you should know that these commits are stored locally. They're completely isolated from the central repository, and if the developers want the changes in the central repository, they'll have to git push it. So now let's say that we have got 3 people. We have got Bob, Alice, and Jake, and they are working on a project X. So now let's say that Bob here makes the changes in the project, commits it, and then pushes it into the central repository. So his changes will be published into the repository with his recent commits. And now let's say that Alice is also working on the same thing and she wants to publish her changes in the central repository. But since Bob and Alice changed the same file in the same line, there will be a conflict. So let me show you how exactly does it happen and how to solve it. So here I have created repositories for Bob and Alice. So they're just in my system at different folders. So since I have to show you this scenario, I have to pretend to be 2 persons at one time. So what I'll do, I'll just click Git Bash here. Now I'm using Git for Windows, so you just don't have to do anything. You just click Git Bash here and it will open up the Git Bash shell. And the same thing I'm going to do for Alice over here. So let me just adjust the screens so that you can see what I'm doing in both of this Git Bash shells. So I hope that you can see the screen over here. So this is Bob's local repository shell that we're using, and this is for Alice. So the first thing that you need to do, you need to initialize your repository. So for that, you have to use git init. And I'll do the same thing for Alice. It's done. And now what I'm going to do, I have already set up my central repository on GitHub. So I'll just add the origin using git remote add origin. So I'll do that for Bob. I'll use this command, git remote add origin. And now you need to provide the link of your central repository that is on GitHub. So I'll just go to my GitHub. So you can find the link over here. So you just copy it, paste it. And I'll do the same thing again for Alice. All right. So now there are files that are existing in my central repository already, so I want to pull those files. So for that, I'll just use this command, git pull origin master. So it has pulled all those files. I'll do the same thing for Alice again. So now if you see their repository, so this is Bob's repository, it has pulled all the files from my central repository, and this is the .git hidden folder. This gets created when you initialize your repository, specifically when we typed git in it. All right. So now let us assume that Bob has made some changes. So let's say this file over here. So I'm just taking very simple examples. So basically there will be code here just so that you can just understand the concepts of conflict. I'm just using simple text files. So let's say that Bob has made some change like this. Saved it. And now Bob wants to commit these changes. So first Bob will check the git status to see, So git status will show you whether a file has been added to the index or not. So if it is in red, it means that it has not been added to the index. So for that, we'll have to add this file. So we'll use the command git add and the name of our file. So now if you check git status, so you can see that it is green now. So it means that it has been added to the index. It is there in the staging area and it is ready to be committed. So now we'll use git commit in order to commit this. And also remember that we have to commit using a message. So I'll just pause this Bob changing Edureka. So it is committed. Now Bob wants to push it to the central repository. So I'll use git push origin master. And it's done. So if you go to your central repository now, so let me refresh this page. So you can see Bob's commit over here. So that means that this file has been changed in the central repository. So now let us go to Alice's local repository. And let's say that Alice does not know that Bob has already made changes in the central repository and she's doing her work in her own local repository and she has changed the file something like this. So we'll close it. Now Alice will also do the same thing. She will add the file and then she will commit the file. You have to pass this flag M. So let me just keep it simple. I'll just write Alice over here. And now she would want to push it the same way that Bob has done, git push origin master. And since it's a centralized workflow, there's only the master branch. So you can see that there is an error that has been rejected. The updates were rejected because the remote contains work that you do not have locally. So it means that something was changed in the central repository, which Alice's local repository doesn't contain. And now it is centralized workflow. And I don't want to mess around with my master branch because my master branch is supposed to always be, and my master branch is always supposed to keep the production deployable code. So instead of just pulling it directly, I'll use Rebase. So what Rebase will do is that it will always have the initial commits that will come from the central repository. It will just add up my commits on top of that workflow or my working tree that shows all my commits. So I'll show how it works. So for that, I'll not just pull it directly. I'll use a different command, git pull rebase origin master. So it is showing that there is a conflict in the content and it is in edureka.txt. And even this message doesn't appear and you're confused where the conflict is, you can do one thing. Let me first clear the screen. You can use git status to see where the conflicting file is. So you can see that edureka.txt. So in order to solve this conflict, I'll use git merge tool. So you can see it has opened up 3 files. So this is the file that Bob has changed. This is what was the original file, and this is what Alice have changed, right? So Alice can take a look, and this is the head where her initial commit right now points to. So she can decide whether to keep the changes or not. And let's say that Alice wants to edit it. She wants to solve the conflict. And let's say that she decides that she wants to keep both the 2 lines. So let's remove all that. Save that file. Again, save and exit. Save and exit. Save and exit. All right, so now you can continue rebasing. So for that, you can use this command. Okay, let me clear my screen so that you can see what I'm typing. So you can use this command git rebase continue. So it has applied my last commit that I was trying to push it onto my central repository. So now the merge conflict is solved, and I should be, or let's say Alice should be successfully be able to push it to the central repository. So let's try it. And the conflict is solved and it is successfully pushed onto the central repository. So let me just show it to you. So here is Alice's commit. So this is how you deal with conflicts when you are using a centralized workflow. So I hope that this is clear. So now let us talk about the feature branch workflow. So if your team is comfortable with the centralized workflow, but they want to streamline its collaboration efforts, and it is definitely worth exploring the benefits of the feature branch workflow. So what happens here is that you dedicate an isolated branch to each feature, and because of this, it is possible to initiate in-depth discussions around the new additions before you try to integrate them into the official project. So the core idea behind this feature branch workflow is that all feature development should take place in a dedicated branch instead of the master branch. And this encapsulation actually makes it easier for multiple developers to work on a particular feature without disturbing the main code base. Because again, I'm telling you, the master branch should always contain production deployable code. So it also means that the master branch will never contain broken code. And this is going to be a huge advantage when you're dealing with continuous integration environments. So again, let us consider the scenario. So this is a feature branch workflow. So they're all working on the features. So let's say that Jake here is working on feature B and Alice and Bob are again working on feature A. So again, first Bob makes a new branch and he pushes that new branch where he has added some features and he has pushed it into the central repository. And then again, Alice wants to push it again. The same things that she might have, some changes that she might have done in the central repository. So then there is an advantage of using the pull request. So pull requests are a way to initiate discussions around a branch. So they give other developers the opportunity to sign off on a feature branch before it's get integrated into the official project. So let me just show you an example of this again. So open up this repositories again. So this is Bob's repository. So let's say that Bob wants to now branch off and work on his new feature. So he just can use this command over here, git branch, and let's say his feature is called feature 1. So now let's check out the feature 1. So now Bob is in the feature 1 branch. So let's say he wants to add something. All right, so just save and exit. And now again, Bob wants to add this file. All right. He will commit this file. Commit done. Just clear it for you. And now you would want to push this branch onto the central repository. So for that, you'll just use the same command, git push origin and the name of his branch. And this will actually create a different branch in the central repository with the same name, and it will serve as a remote tracking branch. And it is done. So if you go to the central repository, now you can see that less than a minute ago, there was a new branch here, which is called the feature 1. So if you go check out this branch in GitHub, you can see it has got this file along with the other files because it was actually branched off from the master with the latest commit where it contained all the files, right? So now if Bob wants Alice to know that he has made some changes because now they're working in a featured branch workflow, so he will file a pull request. So how to do that in GitHub? You just have to go here. Just click this button, new pull request. The base should be master branch and compare the feature 1. And then you can add some comments over here. So you can just create and just let's say that please check it out. So if you want reviews on your branch, whether you have done or developed the feature in the correct way or not, you can actually add reviewers here, and you can actually also assign someone here. So now since my GitHub only have me as a collaborator, I don't have anyone else. So you can add other people who are actually contributing onto this central repository. And then finally, you can click this button. Oops. All right, there seems to be some internet issues with GitHub. All right, but the good part is that I'm actually done with that. You don't have to do anything after you have created that pull request. So what will happen after that is that whoever you add as a reviewer, so they will either get a mail of how you set it up. So they'll get a mail, and then you can also comment, and there'll be a back and forth discussion about what to change or not. And finally, you have to merge it when it has been satisfied. So when you're when your entire team is satisfied on the feature that you have worked on, so someone will finally merge it onto the master branch. So this was all about the feature branch. So pull requests come in handy when you want to carry out discussions with your entire team. So now let us talk about Git Flow. So Git Flow Workflow defines a strict branching model that is designed around the project release. So this is somewhat more complicated than feature branch workflow, but this provides a robust framework for managing larger projects. So this is what the entire branching model kind of looks like. So you don't have to worry, even though it looks very complex, this workflow does not add any new concepts or commands beyond what's required for the feature branch workflow. Instead, the difference is that it assigns very specific roles to different branches and defines how and when they should interact. So in addition to feature branches, it uses individual branches for preparing, maintaining, and recording releases. And of course, you also get to leverage all the benefits of feature branch workflow, the pull requests, the isolated experiments that you do on your feature branches, and more efficient collaboration. So how does it work? So the Git Flow workflow uses a central repository as a communication hub for all developers, just like all other workflows. And the developers, again, work locally and push branches onto the central repository. So the only difference is the branch structure of the project. So instead of a single master branch, so this workflow uses two branches to record the history of the project. So the master branch here actually stores the official release history, and then develop branch that serves as an integration branch for features. And it is very convenient to tag all the commits in the master branch as different versions. So here you have tagged it as version 1.0, 1.0.1, then 1.1.0, something like this. So whatever naming scheme that you are comfortable with. So you have got feature branches. So there are two feature branches mostly. So one is there which majorly focus on the coming release. And the other needs to be worked on for a coming release or a future release. So when a feature is complete, it gets merged back to the develop branch, and feature branch should never interact directly with the master. So feature branches combine with develop branch for all intended purposes to the feature branch workflow, but the Git workflow does not just stop there. So once develop has acquired enough features for a release, or let's say a release date is coming up, so what do? You fork a release branch off to develop. And creating this branch starts the next release cycle. So no new features can be added at this point. So you can only do bug fixes, some hot fixes, some patching up things. And once it is ready to ship, the release gets merged onto the master and tagged with the version number. So this is how Git Flow works. So obviously you'll also find merge conflicts here, but it is very easy to fix because it is more in a structured way. And when you have a lot of people working on a particular application, especially larger applications, you can use Git Flow for that. And in most of the companies, people use Git Flow. So all you have to do, you have to create feature branches, you have to create a develop branch, and you have to follow the Git Flow. So just flow with the Git Flow.
So what is Git Rebase? Rebasing is the process of moving or combining a sequence of commits to a new base commit. Rebasing is the most useful and easily visualized in the context of a feature branching workflow. From a content perspective, if you look at the workflow, rebasing is changing the base of your branch from one commit to another, making it appear as if you would created your branch from a different commit. Internally, Git accomplishes this by creating new commits and applying them to the specified base. It's very important to understand that even though the branch looks the same, it's composed of entirely new commits. Now, the first thing to understand about Git Rebase is that it solves the same problem as Git Merge. Both of these commands are designed to integrate changes from one branch into another. So why do we actually need Rebase? So let's take a look at why we need Git Rebase. So consider what happens when you start working on a new feature in a dedicated branch. So then another team member updates the master branch with new commits. This results in a forked history, which should be familiar to anyone who has used Git as a collaboration tool. The easiest option is to merge the master branch into the feature branch. This creates a new merge commit in the feature branch that ties together the histories of both branches, giving you a branch structure that looks like this. Now, merging is nice because it's a non-destructive operation. The existing branches are not changed in any way. On the other hand, this also means that the feature branch will have an extraneous merge commit every time you need to incorporate upstream changes. If master is very active, this can pollute your feature branch's history quite a bit. While it's possible to mitigate the issue with advanced Git log options. And it can make it hard for other developers to understand the history of the project. So as an alternative to merging, you can rebase the feature branch onto master branch. So this moves the entire feature branch to begin on the tip of the master branch and effectively incorporating all of the new commits in master. But instead of using a merge commit, rebasing rewrites the project history by creating brand new commits for each commit in the original branch. And the primary reason for rebasing is to maintain a linear project history. For example, consider a situation where the master branch has progressed since you started working on a feature branch. You want to get the latest updates to the master branch in your feature branch, but you want to keep your branch's history clean, so it appears as if you have been working off the latest master branch. This gives the latter benefit of a clean merge of your feature branch back into the master branch. So why do we need or why do we want to maintain a clean history? The benefits of having a clean history become tangible when performing Git operations to investigate the introduction of a regression. Hence, rebasing here onto the master branch facilitates a fast-forward merge. And rebasing is a common way to integrate upstream changes into your local repository. Pulling in upstream changes with git merge results in a superfluous merge commit every time you want to see how the project has progressed. On the other hand, rebasing is like saying, I want to base my changes on what everybody has already done. One golden rule, however, is that you must never rebase public history. You should never rebase commits once they have been pushed to the public repository. The rebase would replace the old commits with the new ones, and it would look like that part of your project history abruptly vanished. For example, think about what would happen if you rebased master onto your feature branch. The rebase moves all of the commits in master onto the tip of the feature. The problem is that this only happened in your repository. All of the other developers are still working with the original master. Since rebasing results in brand new commits, Git will think that your master branch's history has diverged from everybody else's. And the only way to synchronize the two master branches is to merge them back together, resulting in an extra merge commit and two sets of commits that contain the same changes. And the original ones are the ones from your rebased branch. Needless to say, this is a very confusing situation. So before you run git rebase, always ask yourself, is anyone else looking at this branch? If the answer is yes, take your hands off the keyboard and start thinking about a non-destructive way to make your changes. For example, the git revert command. Otherwise, you're safe to rewrite history as much as you like. So now let's run a few rebase commands and see how they work. So firstly, let's go to this VM I have whipped up, and I have already branched out my base, and we have made some changes to our branch using the git branch command. Let's call it Edureka branch. Now let's check out from here, and we can see all of our previous commits also are actually available in this new branch. Now you can see that this one is my master branch and this one is my new branch, and all the commits in both the branches. And add a new text file here, and we're going to call it as branch. Now let's move on, guys, and we're going to rebase now. So to rebase our branch to master, we use git rebase master. With that, you can see how under the new branch or the new master branch, you can see all of the changes you have made in the rebased branch, which is Edureka branch. Now, that was the standard rebase. Let's see how we can do the same using the interactive rebase. Running git rebase with the -i flag begins an interactive rebasing session. Instead of blindly moving all of the commits to the new base, interactive rebasing gives you the opportunity to alter individual commits in the process. And this lets you clean up the history by removing, splitting, and altering an existing series of commits. It's like git commit amend on steroids. So to rebase our branch to master, we use git rebase -i, and this rebases the current branch onto the base, which is our master, but uses an interactive rebasing session. So this opens an editor where you can enter commands for each commit to be rebased. These commands determine how individual commits will be transferred to the new base. And you can also reorder the commit listing to change the order of the commit themselves. And once you have specified commands for each commit in the rebase, Git will begin playing back commits applying the rebased commands. Interactive rebasing gives you complete control over what your project history looks like. This affords a lot of freedom to developers, as it lets them commit a messy history while they're focused on writing code, then go back and clean it up after the fact. Most developers like to use an interactive rebase to polish a feature branch before merging it into the main code base. This gives them the opportunity to squash insignificant commits, delete obsolete ones, and make sure everything else is in order before committing to the official project history. To everybody else, it will look like the entire feature was developed in a single series of well-planned commits. The real power of interactive rebasing can be seen in the history of the resulting master branch. To everybody else, it looks like you're a brilliant developer who implemented the new feature with the perfect amount of commits the first time around. This is how interactive rebasing can keep a project's history clean and meaningful. And rebasing can be used to change older and multiple commits, committed files, and multiple messages. While these are the most common applications, Git Rebase has additional command options that can be useful in more complex applications, which is Git Rebase D means during playback, the commit will be discarded from the final combined commit block. Then we have Git Rebase P, which leaves the commit as is. It will not modify the commit's message or content and will still be an individual commit in the branch's history. Then we have Git Rebase X, and during playback executes a command line shell script on each marked commit. A useful example would be to run your codebase's test suite on specific commits, which may help identify regressions during a rebase. Now let's talk about the configuration options as well. So there are a few rebase properties that can be set using git config, and these options will alter the git rebase output look and feel. So rebase.stat, a boolean that is set to false by default, the option toggles display of visual div_stat content that shows what changed since the last debase. And then we have rebase.autosquash, which is a boolean value that toggles the autosquash behavior. And then we have a rebase.missingCommits check, which can be set to multiple values which change rebase behavior around missing commits. And we have warn, which prints warning output in interactive mode, which warns of removed commits. Then we have error, which stops the rebase and prints removed commit warning messages. And then we have ignore, which is set by default. This actually ignores any missing commit warnings. Then we have a rebase.instruction format, which is a git log format string that will be used for formatting interactive rebase display. Now let's move on, guys, and talk about the pitfalls of rebase. So one caveat to consider when working with Git Rebase is merge conflicts may become more frequent during a rebase workflow. So this occurs if you have a long-lived branch that has strayed from the master. Eventually, you will want to rebase against master, and at that time, it may contain many new commits that your branch changes may conflicts with. This is easily remedied by rebasing your branch frequently against master and making more frequent commits. The continue and abort command line arguments can be passed to Git Rebase to advance or reset the rebase when dealing with conflicts. A more serious rebase caveat is lost commits from interactive history rewriting. Running rebase in interactive mode and executing subcommands like squash or drop will remove commits from your branch's immediate log. At first glance, this can appear as though the commits are permanently gone. Using git ref log, these commits can be restored and the entire rebase can be undone. Git rebase itself is not seriously dangerous. The real danger case arises when executing it. And that's all you really need to know and start rebasing your branches. If you would prefer a clean, linear history free of unnecessary merge, you should reach for Git Rebase when integrating changes from another branch. It's a perfectly valid option.
Let us understand the advantages and disadvantages of merge and rebase. First, we'll discuss the advantages of merge. Traceability. Traceability helps keeping information about the historical existence of a feature branch and groups together all commits part of that particular feature. There are a few disadvantages. So in merge, history can become intensely polluted by lots and lots of merge commits. Also, debugging using Git Basic can become much harder due to the merge commits. Now that we've learned the disadvantages and advantages of Git merge, let's discuss the pros and cons of Git Rebase. So the advantages are code history always remains flat and readable in Git Rebase. Clean, clear commit messages are as much part of the documentation of your code base as code comments, comments on your issue tracker, etc. Also, manipulating a single commit is extremely easy. That is, you can revert them back very easily. There are a few disadvantages. Squashing the feature down to a handful of commits can eventually hide context, unless you keep around the entire historical branch with the development history. Also, rebasing does not really play well with pull requests. This is because you cannot see what minor changes someone made if they have rebased. Rebasing can sometimes be extremely dangerous. Rewriting history of shared branches is prone to teamwork breakage. This can be mitigated by doing the rebase on a copy of the feature branch, but rebase carries the implication that competence and carefulness must be employed. The last disadvantage is that rebase sometimes requires a little more extra work. Using rebase to keep your feature branch updated requires that you resolve similar conflicts again and again. Yes, you can reuse recorded resolutions sometimes, but merge wins here. Just solve the conflicts one time and you're set. Moving on, we'll discuss when to really use both of these commands. Now, if you want to see the history completely the same as it has happened, you should always use merge. Merge preserves history, whereas rebase rewrites it. Git merge is a default behavior when you use git pull. Use it as a default if you're not bothering about commit history and want to avoid further problems. Learn to use merge when you're always working with a big team. Now moving on, let us understand when we can use rebase. Rebasing is better to streamline a complex history. Here you are able to change the commit history by using interactive rebase, that is -i. You can remove undesired commits, squash 2 or more commits into one, or edit the commit message. You can also use Git Rebase for creating temporary local branches. They are not necessary for public commit history and won't create any further problems. And as I've already mentioned before, you can use Git Rebase -i, that is interactive, for rewriting your local commit history into a pretty one before pushing it on to a remote server. Your remote server can be GitLab, GitHub, anything of that sort. Now, if the feature branch you're getting changes from is shared with other developers, rebasing is usually not recommended because rebasing process will create inconsistent repositories. For individuals, rebasing makes a lot more sense. That is, if you're working alone or on a small team, make it a habit to use rebase. Now, moving on, let us discuss the similarities between merge and rebase. There is only one similarity. That is, both of these commands can be used to combine two different branches. I'm sure by now you must be pretty aware of that. Since there is only one similarity between both of them, let us understand the differences between merge and rebase and how each of them use different techniques to combine two branches. So as I've already mentioned before, git merge is a git command that allows taking the independent lines of development that git branch created and then eventually integrate them into a single branch. On the other hand, rebase is a git command that moves or combines a sequence of commits to a new base commit that provides easy visualization of feature branching workflow. So rebase has only one line of development or one line of work, but merge on the other hand has several different lines of development. So rebase provides easy visualization of feature branching workflow. Thus, this is the main difference between git merge and git rebase. As you can see the syntax of merge, you have firstly two lines, that is git checkout feature and the second line that says git merge master. You can use the checkout keyword to switch branches. And I'm switching from my feature branch. Currently, I'm working on my feature branch and I want to switch to my master branch. So I'm using the line git checkout feature. The second line that says git merge master allows me to merge the contents of my feature branch into my master branch. Or you can also execute this entire command in one line. That is git merge feature master. On the right hand side, you can see the rebase syntax. Here also it's similar to the one as merge. There is one line that says git checkout feature and the second line that says git rebase -i master. And as I've already mentioned before, use git rebase -i, that is interactive, for rewriting your local commit history into a good one before pushing it onto your remote server. So that is why we use -i, and the rebase keyword is used to execute rebasing. I hope both of these differences are clear. Now let's look at the intricate details and the differences between git merge and git rebase. The first difference is based on the project history. Rebase provides a much cleaner project history than git merge. I'm pretty sure you're clear of that by now. The second difference is navigation. It is easier to navigate through the project in rebase than it is in git merge. The third difference is the number of steps. Merge is a one-step operation with one place to resolve conflicts, and the commits that were reachable from the branch always remain reachable. Rebase, on the other hand, is a multi-step operation. Here there are more steps, but each of these steps are comparatively small. The last difference is the context. In git merge, the developer can see when the upstream changes were incorporated into the feature. On the other hand, in rebase, the developer cannot see when the upstream changes were incorporated into the feature. Hence, this is also a difference between git merge and git rebase. Moving on to the last part of this session, which one is better for which situation? Both merge and rebase can be used to combine two branches. Merge command just unifies your work with the commit without changing history, while rebase apply feature branch changes on top of the master branch and change the entire history. If you prefer to have a clean history, then you can always choose rebase. If you need to preserve the history changes, then merge would definitely be the best choice. If you and your team are not familiar with or do not understand the intricacies of rebase, then you probably shouldn't use it. In this context, always merge is the safest option. But if you and your team are extremely familiar with both of these options, then the main decision revolves around this. Do you value more a clean linear history or the traceability of your branches? In the first case, go for a rebase policy. In the latter, go for the merge one.
Now let us talk about the definition of Jenkins. So Jenkins is an open source automation tool written in Java with plugins built for continuous integration purpose. Jenkins is used to build and test your software projects continuously, making it easier for developers to integrate changes to the project and also making it easier for the users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with a large number of testing and deployment technologies. With Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle processes of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. Jenkins achieves continuous integration with the help of plugins. Plugins allow the integration of various DevOps stages. If you want to integrate a particular tool, you just need to install the plugins that are required for that tool. For example, the various plugins that are supported by Jenkins include Git, Maven2 project, Amazon EC2, HTML publisher, and so on. So this was the definition of Git. Now, if you talk about the advantages of Git, as already discussed, it is an open source tool and it has a great community support. It is very much easy to install and almost has 1000 plus plugins to ease your work. If a plugin does not exist, you can code it and share it with the community. It is free of cost and it is built with Java, and hence it is portable to all the major platforms. So this was all about the Jenkins. Now let us talk about why should we integrate Git with Jenkins, or why they are used together. So as already discussed, Git is a source control manager, and that's where you keep your source code for tracking all the code changes that happen over the time and to baseline the versions when they are ready for release. Jenkins, on the other hand, is a continuous integration solution. It was devised to automate most of the tasks that a developer has to do while developing a new application. Without a CI solution, a developer has to spend much time doing these repetitive, non-productive tasks. So let us take an example of a new feature in a web application. So what happens here is a developer will be identified and assigned the task. So he takes the existing code base from the source code, say for example Git, makes his changes, carries out unit testing, ensures the code quality manually, and checks the new code back into the Git. Then he has to build the code, deploy it into the integration instance, run integration testing, and once the change seems satisfactory, he raises a request for production deployment. Now, if we only had a minion to take care of this testing, building, quality checks, and deployment sections, the poor developer could have focused better on the stuff that he's really good at. That is, implementing and improving the features logic. So this minion is nothing but Jenkins. It acts as an orchestrator which runs all of these activities once the change is checked into the source control, and thus gives a quick feedback to the developer whether the changes he has made are good enough for the production deployment or not. So Jenkins is extremely flexible, open source, and has a lot of plugins that can do almost anything that you wish to. So these were the reasons of using Git with Jenkins. Now next comes the question of how do they work together. So here I'll be showing you one demo, and these are the steps that are covered in this demo. So first we create a sample program. So you can create any program that you want, be it a Python program or a Java program or any other program. Then in the second step, we create a Jenkins job. And once we create the Jenkins job, we add the program that is created in the first step to the GitHub. So for that, we create a GitHub repository, a public GitHub repository, and upload the code on that repository using Git. And in the next step, you add Git plugin in Jenkins. And finally, we configure the Jenkins job based on the GitHub repository. So let me just show you how do you do this. So what we need to do here is you have to create a directory on your desktop, and you have to create one Python file here. So the name of the file is, say for example, anything that you want, or in this case I've written my file. Okay, so this is basically a simple Python file with a very simple code, print hello world. That's it. So what we need to do here is you can open your GitBash here. So first let us initialize an empty Git repository here using the command git init. So an empty repository has been initialized here in this demo folder. So now let us just check the status here using the command git status. So as you can see here, this file, it is in red color, myfile.py. So red color means here that it has not been added. So just to add the file, you can use the command git add and the dot. You can also specify the name of the file here, like myfile.py. But if there are multiple files that you need to add, then you can use the dot symbol.
So the file has been added, and now let us just verify this. Okay, so as you can see here, previously it was red and now it is green here. So after adding the file, now let us just commit these changes. For that, the command is git commit -m, any message if you want, add my file.py. So we have now committed these changes. So what we need to do here is we have to push this myfile.py on the GitHub repository. So for that, let me just go to my GitHub account. Okay. Okay guys, so what we need to do here is we have to create a public repository. For that, you have to click on this repositories on your GitHub main page, and you have to click on new. So once you click on new, you can name the repository, say for example Git Jenkins integration or whatever name that you want, and the description is optional here. And if you want, you can initialize this repository with a readme and click on create repository. So this has been created here. So guys, now we have created a public repository on GitHub, and now our task is to upload this file called myfile.py onto the public repository on GitHub. For that, we will have to first connect to it, and the command for that is git remote add origin and the link of that repository. And how do you get that link? So when you create this repository, here you get the link. Okay, so just copy it and paste it here. So this has been added, and now we can push our content there. So for that, the command is git push -u origin and master. Here you can see, if you just refresh this page, okay, so myfile.py, here it has been added onto our public repository on GitHub. So now what our job is, we have to create a Jenkins job. First, log in onto your Jenkins homepage, enter the username and the password. So now what we'll do here is we will create here a new job, Jenkins Git demo, and choose the freestyle project, click on OK. Okay. So here what you need to specify the source code management. In the source code management, okay, before that you have to download the Git plugin. So how do you do that? Go to manage Jenkins. Here as you can see left hand, click on manage plugins. Okay, if you already have Git plugin installed on your Jenkins, you can click on install it here. So if it is already downloaded, yeah, as you can see here on my system, it has already been downloaded. You can find it here. Else, if it is not available, like if it is not installed, you can click on available, search here by typing git and download it. So this is how you download the Git plugin. And going back to our project, let us just configure this now. Okay, so this was our project that we created, Jenkins Git demo. So let us just configure this project. So in the source code management section, here you must click on Git and you enter the Git repository here. Copy this link and you paste it here. Click on apply. It has been added. And here in the build trigger section, we have to click on poll SCM. So here we have to enter the cron expression. Periodic scheduling of Jenkins job is done through poll SCM. So what you need to do here is, in my case, I'm typing here 5 asterisks separated by space. I hope you guys are aware of the cron syntax. So 5 asterisks here mean that our Jenkins job will run every single minute. So every single minute, our Jenkins job will check for the source code change. If there is any change, it will run, like it will build the job, it will build the code. This is the meaning of that. Click on apply. Yeah. And now since we have a Python code, so what we'll do here, we will add a build step. Since guys, I'm using here Windows operating system, so I'm clicking on execute Windows batch command. If you are using Linux or Mac OS, you can execute shell script. Okay, so click on here. So since I have a Python code there, so I will type Python, like the command to run the Python file, myfile.py. Okay, fair enough. Click on apply, save. So now we will build this project. Okay, as you can see here, our build was successful. So this was the hello world thing that we had written in our program, and here it shows success. Okay, so now what we will try to do is we will do some changes there in the my file. We will add a few lines and then we will see what happens. Control C. Say for example, hello world. Now we will say, how are you? Save it. Okay, so now we have to push these changes onto the public repository of GitHub. So we will do that through Git. So now let us check the status first. Okay, so modified. As you can see here, the file has been modified and that has been shown here. So for that, we will first add. Now let us check the status. So now we will commit this file. Some message if you want, modified my file. Press enter. So now we have to push these changes. So for that, the command is git push -u origin master. So these changes have been pushed onto the GitHub account. So let me just refresh this page. Okay, so as you can see here, modified my file. This was the commit message that we had written. So our changes have been reflected here. If you can see here, print how are you? We had added this line, if you remember. So now we will see what happens to Jenkins now. So here we will click on build now. So if you click on console output here, okay, started by an SCM change. So since there was change in the source code, that triggered the Jenkins job. So here you can see hello world and how are you. Both the lines have been displayed here and it is success.
So first of all, what is a webhook? Now the concept of a webhook is very simple. It is an HTTP callback, an HTTP post which occurs when something happens through a simple event notification via HTTP post. To make it simple, GitHub will perform a post request with a payload object which contains data about the triggered event to your defined webhook URL. So upon triggering this event, it will allow us to automate the executions of some actions based on your GitHub events. For example, if after each push to the master branch, we want to package or deploy our software, we can simply add a webhook to the Jenkins task responsible for packaging or deploying the service. So GitHub webhooks in Jenkins are used to trigger the build whenever a developer commits something to the master branch. So at least let's first look out in theory. Let's see how to build a webhook in GitHub and then add this webhook in Jenkins. So first we go to our project repository and head straight to the settings on the right corner. We're going to select the option of webhooks and click on add webhooks. Here we have an open field for payload URL where we are going to put in our Jenkins address followed by a GitHub-webhook extension. This payload URL is the URL where our Jenkins is running, and we are adding GitHub-webhook to tell GitHub that it is a webhook, plain and simple. Next we have content type. So here we are basically trying to specify what kind of data we want in our webhook. We are going to select JSON data. Next we have secret. In this field, we are going to secure our webhook. So we can provide a secret in our webhook and ensure that only applications having this webhook can use it. And then we have SSL verification. This SSL checker will help you diagnose problems with your SSL certificate installation. You can verify the SSL certificate on your web server to make sure that it is correctly installed valid, trusted, and doesn't give any errors to any of your users. Now, which events would you like to trigger this webhook? In this, you particularly have three options. Now, if you want only to send data when someone pushed into your repository, you use the just the push event. Same thing, but if you want somebody to get notified whether there is a push or a pull event, you select send me everything. And finally, you have let me select individual events in which you can configure for what events you want your data. And then click create and a webhook will be successfully created. In my case, I will be using the IP address where my Jenkins is running. Now here is a problem you have to take care of if you're running Jenkins on localhost. Then switching your IP for localhost will not work because webhooks can only work when they are exposed to the internet. In such a case, you want to make your localhost 8080 exposed to the internet, and you can use various tools such as ngrok in cases like these. Now let's see how to use this webhook in Jenkins. So next you want to log into Jenkins and create a new item or a new job. Here you can click on the kind of project you would like it to be. And under source code management, you're going to select the option Git and put in your repository URL in the given field. Then in build triggers, you want to select the GitHub hook trigger for Git SCM polling and save your changes. Now, when you make any updates in this particular Git repository, you will get an update on your Jenkins job. And in this way, we can add our webhook to our job and ensure that every time a developer commits code to GitHub, our build will be triggered. Now that we've done it theoretically, let's go ahead, move on with our demonstration. So this is my GitHub repository opened up. I'm using the virtual machine to run this on Ubuntu. So this is a demo repository. And here I'll go to settings, select webhooks, and add a webhook. Then I'm going to go to my Jenkins and select the URL. So it's going to start out with your regular http:// your IP address and your port number. After the final slash, you're going to type in GitHub webhook and don't forget to end it with a slash. Next, in content type, we are going to be using application or a JSON file. I'm not going to keep any secret or anything, and in events, I'm just going to keep just the push event. You can go ahead and use any of the others. This is just for demo purposes, hence we're just going to keep it simple. Then I'm going to add the webhook. Then you'll get a message like this which says, okay, that hook was successfully created. So you know your hook is created. Like I said, if this doesn't work, you can use something like my public IP or an ngrok to make this run. Okay. Next, let's move on to Jenkins and create a new job. So we're going to start here and create a new job. Let's call it webhook 1. I'm going to select the freestyle project and click on OK. All right. So under source code management, I'm going to select Git. I'm going to select the link of my repository and put it right here. Now the condition is whenever a change happens in this repository, I want my Jenkins to be automatically triggered, right? So I'll select build triggers, and here I'm going to select GitHub hook trigger for Git SCM polling. So this job basically will listen for triggers from this particular repository. Yes? All right. Let's go down, let's apply and save. So now let's go back to our GitHub and try to make some changes in our sample file. Let's just type some demi text for Jenkins. and commit changes. And if you go down now, you can see this has automatically been triggered. The whole idea of this is GitHub should basically send a notification to Jenkins that there has been a new commit pushed to that particular repository using the webhook that we've just created. Okay? And that is how we integrate a Jenkins job with webhooks in GitHub.
Why GitOps? Previously, companies usually had separate operations and development teams, and unfortunately, they did not talk to each other too much. Luckily, we have DevOps, which tries to address this by ensuring increased collaboration so that operations and development teams work closely together. In an ideal world, it meant that you have the same people who are both writing the applications and operating the applications. It means automating as much as possible to reduce the need for manual human input when operating applications. So, DevOps was a cultural change. Now, with GitOps, it takes it to the next level, where teams have an operating model where they not only define the infrastructure as code, but also make deployments and changes to infrastructure as code by submitting pull requests that people can eventually review and approve collectively. With GitOps, you make it ubiquitous to have continuous integration on a continuous delivery server when deploying your application. Now, once you submit a change, the server will pick it up immediately, pull the changes, execute any automatic tests, execute any quality checks, and eventually build the artifact. This artifact is then published to an artifact repository and eventually deployed to infrastructure. By applying GitOps, there is a source of truth for both your infrastructure and application code, allowing development teams to increase velocity and eventually improve system reliability. With all of this said, what exactly is GitOps? On the surface, it is quite simple. GitOps is centered around using a version control system such as Git to house all information, documentation, and code for a cluster deployment, and then use automated directors to deploy changes to the cluster. However, once you dig past the surface, you discover that it's far more complex than that. GitOps is the operational practice which uses Git as a single source of truth. It is to be noted that source control repository on Git becomes the source of truth and not the actual servers or the clusters. This is nothing but having your infrastructure as a code, which means all your infrastructure setup is inside a code base. It also includes the automation of deployments, rollbacks, and much more. Git repository can be leveraged for version controlling system, peer reviewing system, automating and deploying process for the production environment. Using Git itself, developers are now doing continuous delivery and automated pipelines. Additionally, the webhooks from the Git can be leveraged to push these configurations into the development and test environments. So once you merge that particular pull request onto the main branch, the deployment to production eventually happens. On the other hand, GitOps also allows automating everything using pipelines and deploying that to production once you merge the code into your production branch. It is called GitOps because all the configurations are managed in the Git repository. Many developers deploy the infrastructure code as well as a part of the automation process by using only one repository for an application or a service and have a separate repository for each of them. Now, let's say you have three environments, namely development, test, and production. There should also be three branches that are named the same, that is development, test, and production. This is done to map each of these branches to different environments in the Kubernetes cluster. Once you push the changes onto that particular branch, there will be a relevant automated pipeline which will be eventually set up. This means that whenever there is a change for that specific branch, the pipeline deploys to that environment. It also identifies, tests, and verifies that the environment looks all right. This way, when a developer makes a change in their development branch, and once the development branch succeeds, they will eventually be able to merge pull requests in order to join it to the production branch. And once you click on merge, that is when it will all deploy to the production environment. If you want to do a rollback, you can simply create another pull request to roll back to that particular previous state of the branch. So, if a user goes and changes the code in the Git repository, it creates a container image, and that container image is pushed to the container registry, which is eventually updated into a config updater. Once you create a pull request to merge to a different branch, that is when it deploys to the concerned branch, and then it tests whether these are good. This way, every time you raise a pull request, you know what you're merging, and that pull request is being reviewed by somebody based on the success criteria of that particular automated branch pipeline. This is how GitOps helps teams in solving the automation problem. Thus, GitOps can be summarized as these two things. The first one is that it is a path towards a developer experience for managing applications, where end-to-end CI/CD pipelines and Git workflows are applied to both operations and development. The second one is that it is an operating model for Kubernetes and other cloud-native technologies, providing a set of best practices that unify deployment, management, and monitoring for containerized clusters and applications. GitOps is based off of four main principles. So to start managing your cluster with GitOps workflows, the following must be in place. The first one is that the entire system described declaratively. Kubernetes is just one example of many modern cloud-native tools that are declarative and that can be treated as code. Declarative means that configuration is guaranteed by a set of facts instead of by a set of instructions. With your application's declarations versionized in Git, you have a single source of truth. Your applications can then easily be deployed and rolled back to and from Kubernetes. And even more importantly, when disaster strikes, your cluster's infrastructure can also be dependably and quickly reproduced. The second one is the canonical desired system state versionized in Git. With the declaration of your system stored in a version control system and serving as your canonical source of truth, you have a single place from which everything is derived and driven. This trivializes rollbacks, where you can use a Git revert to go back to your previous application state. With Git's excellent security guarantees, you can also use your SSH key to sign commits that eventually enforce strong security guarantees about the authorship and provenance of your code. The third one is approve changes that can be automatically applied to the system. Once you have the declared state kept in Git, the next step is to allow any changes to that system to be automatically applied to your system. What's significant about this is that you do not need cluster credentials to make a change to your system. With GitOps, there is a segregated environment of which the state definition lives outside. This allows you to separate what you do and how you're going to do it. The fourth and the last principle is that software agents to ensure correctness and alert on divergence. Once the state of your system is declared and kept under version control, software agents can inform you whenever reality does not match your expectations. The use of agents also ensures that your entire system is self-healing. And by self-healing, we do not just mean when nodes or pods fail. Those are handled by Kubernetes, but in a broader sense, like in the case of human error. In this case, software agents act as the feedback and control loop for your operations. Now I assume all of you have a fair idea of what GitOps is. Moving on, we'll discuss how it works. So, how does GitOps work? It's pretty complicated, but let's try and understand this in a simple way. Imagine you have every single piece of documentation, all of your YML files, and every bit of necessary code required for Kubernetes contained in a single Git repository. With the help of a few automation tools, anyone who is tasked with managing that Kubernetes deployment can do a pull request, edit the code, and then eventually issue a merge request to the Git repository. So once the merge request is complete, the automated GitOps operator detects something has changed. Another automator declares the change is operational, and the change is then automatically deployed to the cluster. So basically, there are two important things you need to know. The first one is that changes are made via pull requests. Operating via pull requests reduces the number of variables, which eventually transform deployments into crime scenes. Fortunately, code deployers are no longer awarded war hero status for manually moving bits from point A to point B. The second thing is that convergence ensures eventual consistency. If a group of configuration updates is made by a human, the observed state in the cluster can drift from the desired state declared in Git, thus causing divergence. When the desired and observed states are different, Kubernetes provides a convergence mechanism to drive the observed state towards what the teams declared as a desired state in version control. Now let's discuss a typical developer workflow for creating or updating a feature. A pull request for a new feature is pushed to GitHub for review. The code is reviewed and approved by a colleague. So after the code is revised and reapproved, it is merged to Git. The Git merge eventually triggers the continuous integration and build pipeline. It runs a series of tests and eventually builds a new image and deposits this new image to a registry. The deployment automator watches the image registry, notices the image, pulls the new image from the registry, and updates its YML in the config repository. The deployment synchronizer, which is installed to the cluster, detects that the cluster is out of date. It pulls the change manifest from the config repository and deploys the new feature to production. So in this workflow that I just talked about, automation is extremely crucial. So as to keep everything moving with a level of efficiency that cannot be matched with purely manual administration. The GitOps core machinery is in its CI/CD tooling with the critical piece being continuous deployment that eventually supports Git cluster synchronization. So now we'll move on and talk about the benefits of applying GitOps best practices. The first one is increased productivity. Continuous deployment automation with an integrated feedback control loop speeds up mean time to deployment. Your team can ship 30 to 100 times more changes per day, increasing overall development output by almost 2-3 times. The second reason is enhanced developer experience. Push code and not containers. Developers can use familiar tools like Git to manage updates and features to Kubernetes more rapidly without having to know the internal of Kubernetes. Newly onboarded developers can get quickly up to speed and be productive within days instead of months. The third benefit is improved stability. When you use Git workflows to manage your cluster, you automatically gain a convenient audit log of all cluster changes outside of Kubernetes. An audit trail of who did what and when to your cluster can be used to meet SOC2 compliance and ensure stability. The fourth benefit is higher reliability. With Git's capability to revert or rollback and fork, you gain stable and reproducible rollbacks. Because your entire system is described in Git, you also have a single source of truth from which to recover after a meltdown, reducing your mean time to recover from hours to minutes. The fifth benefit is consistency and standardization. Because GitOps provides one model for making infrastructure, applications, and Kubernetes add-on changes, you have consistent end-to-end workflows across your entire organization. Not only are your continuous integration and continuous deployment pipelines all driven by pull request, but your operations tasks are also fully reproducible through Git. The last and most important benefit is stronger security guarantees. Git's strong correctness and security guarantees backed by the strong cryptography used to track and manage changes, as well as the ability to sign changes to prove authorship and origin is key to a secure definition of the desired state of the cluster.
Let us begin with our first topic, that is the basic level of or the beginner level of interview questions. So the first question is, what is Git? Git is a distributed version control system. It lets you track changes made to a file and allows you to revert back to any particular change that you wish to. It is a distributed architecture that provides many advantages over other version control systems like the SVN. One of the major advantages is that it does not rely on a central server to store all the versions of a project's files. So what happens in Git is, instead, every developer clones a copy of a repository, as you can see in this diagram, and he has the full history of the project available on his hard drive. So whenever there is a server outage, all you need to do is just copy one of your teammates' local Git repository and bang, you have the code on your system. So there is one central cloud repository where the developers can commit changes and share them with the other team members. So this is what Git is in a nutshell. So the next question is, what is a distributed version control system? So these are the systems that don't rely on a central server to store a project file and all its versions. You can see the diagram that is on your slide right now. In a distributed version control system, every contributor can get a local copy or a clone of the main repository. Here, every programmer can maintain a local repository, which is actually the copy or the clone of the central repository, which is present on their hard drive. So developers can commit and update their local repository without any hassles. With an operation called pull, they can update their local repositories with the new data from the central server, and pull operation affects changes to the main repository from their local repository. The next question is, what are the advantages of using a version control system? So with version control system, all the team members are allowed to work freely on any file at any given time. Version control system gives you the flexibility to merge all the changes into a common version. All the previous versions and variants are neatly packed up inside the version control system, or the VCS. You can request any version at any time as per your requirement, and you'll have a snapshot of the complete project right at your hand. So whenever you save a new version of your project, your VCS requires you to provide a short description of the changes that you have made. Additionally, you can see what changes are made in the file's content. This helps you know what changes have been made in the project and by whom. Finally, a distributed version control system like Git allows the team members to have a complete history of the project, so that if there is a breakdown in the central server, you can use any of your teammates' local Git repository. So these were a few advantages of using the version control system. The next question is, what is the difference between Git and SVN? So Git is a decentralized version control tool, whereas SVN is a centralized version control tool. Git belongs to the third generation of the version control tools, whereas SVN belongs to the second generation of the version control tools. So what happens in Git is clients can clone entire repositories on their local systems, whereas in SVN, version history is stored on the server side of the repository. In Git, commits are possible even if you're offline, whereas in SVN, only online commits are allowed. So in Git, the push and pull operations are comparatively faster, whereas in SVN, the push-pull operations are comparatively slower. Git works are shared automatically by commit command, whereas in SVN, nothing is shared automatically. So these were a few differences that you can mention in this question. Okay, so the next question is, what is the difference between Git and GitHub? So as we have already seen, Git is a version control system of distributed nature that is used to track changes in the source code during software development. So Git aids in coordinating work among programmers, but it can be used to track changes in any set of files. So the main objectives of Git are speed, data integrity, support for distributed nonlinear workflows. Whereas GitHub is a Git repository hosting service, plus it adds many of its own features. So GitHub provides a web-based graphical interface. It also provides access control and several collaboration features, basic task management tools for every project. So the next question is, what language is used in Git? So here, instead of just telling the name of the language, you should also mention the reason for using this language as well. So Git uses C language. Git is fast, and C language makes this possible by reducing the overhead of run times associated with high-level languages. The next question is, mention the various Git repository hosting functions. The following are the main Git repository hosting functions, as you can see on the slide: GitHub, GitLab, Bitbucket, SourceForge, and Git Enterprise. And as per my opinion, the GitHub is the most popular among these options. So the next question is, what is a repository in Git? So repository in Git is a place where Git stores all the files. So Git can store all the files either on the local repository or on the remote repository. The next question is, what is a bare repository in Git? So a bare repository in Git contains information about the version control and no working files, and it doesn't contain the special .git subdirectory. Instead, it contains all the contents of the .git subdirectory directly in the main directory itself, whereas the working directory consists of two things. The first one is a .git subdirectory with all Git related revision history of your repository, and the second one is a working tree or checked out copies of all your project files. The next question is, what is a commit message? So a commit message is nothing but an information that you provide along with the command called commit, so that you're aware of what exactly that change the developer or the programmer is doing while committing any operation or any change. So as you can see here, the syntax for commit messages: git commit, the option, and the message that you want to write. So the next question is explain some basic git commands. So as you can see here on the slide, these are the various commands, some basic git commands that you should be aware of. So the first command is the git init command. As we have already seen what is a repository in Git, so this command is used to create a new local repository. The next command is the git status command. So this command lists the files that you have changed and those you need to add or commit. The next command is git clone. So this command creates a working copy of a local repository, and the syntax is git clone and the URL. The next command is the git add command. So this command adds one or more files to the staging area of Git. So what exactly is staging area? We will see in the subsequent part of this session. The next command is git commit command. As we have seen previously what commit message is, that time we discussed just one thing about the commit command. So this command commits any files you have added with git add and also commits any files you have changed since then. And the syntax is pretty much simple: git commit and the option. The next command is git push origin master. So this command sends changes to the master branch of your remote repository. So these are some basic commands that you can explain. So the next question is, how do you fix a broken commit? So in order to fix any broken commit, you can use the command git commit -- amend. So when you run this command, you can fix the broken commit message in the editor. So the next question is, what is a conflict in Git? So Git can handle on its own most merges by using its automatic merging features. There arises a conflict when two separate branches have made edits to the same line in a file, or when a file has been deleted in one branch but it has been edited in the other branch. So conflicts are most likely to happen when working in a team environment. The next question is, how do you resolve a conflict in Git? So you can refer the diagram for more information about this question. So there are a few steps that you need to follow to resolve a conflict in Git. The first step is identify the files that have caused the conflict. In the second step, you make the necessary changes in the files so that the conflict does not arise again. In the third step, you add these files by using the command git add. And finally, to commit the changed file, use the command git commit. So these were the 4 steps that you need to follow to resolve a conflict in Git. The next question is, how do you revert a commit that has already been pushed and made public? So there can be 2 approaches to tackle this question, and you must include both the approaches in your answer because any one of them can be used depending upon the situation. So the first approach is remove or fix the bad file in a new commit and then push it to the remote repository. This is the most obvious way to fix an error. Once you have made the necessary changes to the file, then commit it to the remote repository using the command git commit -m and the commit message. In the second approach, you can create a new commit that undoes all the changes that were made in the bad commit. To do this, you need to use one command called git revert. So we will talk about git revert in the subsequent part of this session. Syntax for git revert is very simple. So git revert and the name of the commit or the commit ID. The next question is, what is subgit? So subgit is a tool for SVN to Git migration. It can create a writable Git mirror of a local or a remote subversion repository and use both subversion and Git as long as you like. Now you can also include some of the advantages, like you can do a fast one-time import from subversion to Git or use subgit with Atlassian Bitbucket server. We can use subgit to create a bidirectional Git SVN mirror of an existing subversion repository. You can push to Git or commit to subversion as per your convenience. Synchronization will be done by subgit. So the next question is, what is the difference between git pull and git fetch? Git pull command pulls new changes or commits from a particular branch from your central repository and updates your target branch in your local repository. Whereas git fetch is used for the same purpose, but it works in a slightly different way. When you perform a git fetch, it pulls all new commits from the desired branch and stores it in a new branch in your local repository. If you want to reflect these changes in your target branch, git fetch must be followed with a git merge. So in this case, your target branch will only be updated after merging the target branch and the fetched branch. So just to make it very simple for you, there's one equation that you must remember. So git pull equal to git fetch plus git merge. So what is the staging area or the index in Git? Before completing the commits, any change can be formatted and reviewed in an intermediate area known as the staging area or the index. So you can refer the diagram on your slide for more reference. So this will give you a clear-cut idea of what exactly is the staging area. The next question is, what is the use of Git InstaWeb? Git InstaWeb is used to automatically direct a web browser and run a web server with an interface into your local repository. So now we will have a look at the intermediate level of interview questions. So the next question is, what is Git isTree? So Git isTree represents a tree object including the mode and the name of the each item and the SHA1 value of the blob or the tree. The next question is, what is Git stash? So in this question, you should first explain the need for Git stash. So often when you have been working on part of your project, things are in a messy state and you want to switch branches for some time to do something else. So the problem here is you don't want to do a commit of half done work just so that you can get back to this point later. So to solve this issue, there is one provision called Git stash. So stashing takes your working directory, that is your modified track files, and stage changes and saves it on a stack of unfinished changes that you can reapply at any time. The next question is, what is the function of git stash apply? So as we have seen previously, if you want to continue working where you had left your work, then git stash apply command is used to bring back the saved changes onto your current working directory. The next question is, what work is restored when the deleted branch is recovered? So the files which were stashed and saved in the stash index list will be recovered back. Any untracked files will be lost. Also, it is a good idea to always stage and commit your work or stash them. So if you want to fetch the log references of a particular branch or a tag, then run the command git reflog and the reference name. So we will see about git reflog in the subsequent part of this session. Okay, so the next question is, explain the difference between git status and git diff. So git diff depicts the changes between the commits, commit and the working tree, etc. Whereas git status shows you the difference between the working directory and the index. Git status is helpful in understanding Git a bit more comprehensively. Git diff is similar to git status. The only difference is that it shows the differences between the various commits and also between the working directory and the index. The next question is, mention the differences between the git clone and git remote. So git remote creates an entry into your git config that specifies a name for a particular URL, whereas git clone creates a new git repository by copying an existing one located at the URL. The next question is, what is git stash drop? So git stash drop command is used to remove the stashed item. It will remove the last added stash item by default, and it can also remove a specific item if you include it as an argument. The next question is, how do you find a list of files that has changed in a particular commit? So to get a list of files that has changed in a particular commit, use the command, as you can see here on this slide, git diff tree -r and the hash. So given the commit hash, this will list all the files that were changed or added in that commit. The -r flag makes the command list individual files rather than collapsing them into the root directory names only. You can also include the below mentioned point, although it is totally optional, but this will help you impress the interviewer. So the output will also include some extra information which can be easily suppressed by including two flags. So as you can see here on the screen, this command, here you have included two flags, the no commit ID and the name only. So here the no commit ID will suppress the commit hashes from appearing in the output, and the name only flag will only print the name of the files instead of their paths. The next question is, what is the function of git config? So Git uses your username to associate commits with an identity. The git config command can be used to change your Git configuration, including your username. So suppose you want to give a username and an email ID to associate a commit with an identity so that you can know who has made a particular commit. So for that, there are two commands, as you can see on this slide: git config -- global user.name and your name that you want to give to the user, and then the email. So the command for that is git config global user.email and your email address. So the next question is, what does the commit object contain? So commit object basically contains three components. First, a set of files representing the state of a project at any given point of time. The second one is the reference to the parent commit objects. And the third one is an SHA1 name, which is a 40-character string that uniquely identifies the commit object. The next question is, describe the branching strategies that you have used. So this question is asked to test your branching experience with Git. So here we are going to discuss the three branches, starting with the first one, that is a feature branching. So a feature branch model keeps all of the changes for a particular feature inside of a branch. When the feature is fully tested and validated by automated tests, the branch is then merged into the master. The second is the task branching. In this model, each task is implemented on its own branch with the task key included in the branch name. It is easy to see which code implements which task by just looking at the task key in the branch name. And the third branching is the release branching. Once the develop branch has acquired enough features for a release, you can clone that branch to form a release branch. Creating this branch starts the next release cycle, so no new features can be added after this point. Only bug fixes, documentation generation, and other release-oriented tasks should go in this branch. Once it is ready to ship, the release gets merged into the master and tagged with a version number. In addition, it should be merged back into the develop branch, which may have progressed since the release was initiated. So this was about the branching strategies. Okay, so the next question is, explain the advantages of forking workflow. There is a fundamental difference between the forking workflow and the other popular Git workflows. Rather than using a single server side to act as a central code base, it gives every developer their own server-side repository. The forking workflow is commonly seen in public open source projects. A crucial advantage of forking workflow is that contributions can be generated even without needing everybody to push to a single central repository that leads to the clean project history. Developers can push to their own server-side repositories, but only the project maintainer can push to the official repository. If developers are ready to publish a local commit, then they push the commit to their own public repository and not the official one. So after this, they go for a pull request with the main repository that lets the project maintainer know an update is ready to be integrated. So these were a few advantages of forking workflow. So the next question is, how will you know in Git if a branch has already been merged into the master? So the answer to this is pretty direct. So there are two commands to check this. The first command is the git branch -- merged. So this command lists the branches that have been merged into the current branch. And the second one is the git branch -- no - merged. So this command lists the branches that have not been merged. The next question is, why is it desirable to create an additional commit rather than amending an existing commit? So there are two reasons for this question. So the first one, the amend operation destroys the state that was previously saved in a commit. If there is just the commit message that is being changed, then that is not a problem. But if the contents are being amended, then the chances of eliminating something important remains more. The second reason is that abusing git -- amend command can result in the growth of a small commit and acquire unrelated changes. The next question is, what does hook comprise of in Git? This directory consists of shell scripts that are activated if you run the corresponding Git commands. For example, Git will try to execute the post commit script after you have run a commit. The next question is, in Git, how would you return a commit that has just been pushed and made open? So one or more commits can be reverted through the use of git revert. This command in a true sense creates a new commit with patches that cancel out the changes introduced in the specific commits. If in case the commit that needs to be reverted has already been published or changing the repository history is not an option, then in such cases, git revert command can be used to revert the commits. So alternatively, there is always an option to check out the state of a particular commit from the past and commit it anew. The next question is how to remove a file from Git without removing it from your file system.
So one has to be very careful during a git add, else you may end up adding the files that you didn't want to commit. However, git rm command will remove it from both your staging area as well as your file system, but this may not be what you want. So instead you can use the command, as you can see here, git reset file or the echo file name and .git ignore. So this means that git reset is exactly opposite to the git add command. So the next question is, could you explain the git workflow? So to record the history of the project, Git Workflow employs two parallel long-running branches. The first one is the master branch and the second one is the develop branch. So the master branch is always ready to be released on live with everything fully tested and approved. That is production ready state. The hotfix branch in master is used to quickly patch the production release. These branches are a lot like the release branches and the feature branches, except that they are based on master instead of the develop. And the second branch is the develop branch. This is the branch to which all the feature branches are merged and where all the tests are performed. Only when everything's been thoroughly checked and fixed, it can be merged into the master. Here there's one more branch called feature branch. So each new feature should reside in its own branch, which can be pushed to develop branch as their parent one. So the next question is, explain the difference between the head, working tree and index. So guys, you can refer the diagram that is on your slide for clear understanding. The working tree or the working directory or the workspace is the directory of source files that you're able to see and edit. So the index or the staging area is a single large binary file which lists all the files in the current branch, their SHA1 checksums, timestamps, and the file name. It is not another directory which contains a copy of files within it, whereas head is used to refer to the last commit in the currently checked out branch. So the next question is, what is the difference between fork, branch, and clone? A fork is a copy of a repository. Normally, you fork a repository so that you're able to freely experiment with changes without affecting the original project. Most commonly, forks are either used to propose changes to someone else's project or to use someone else's project as a starting point of your own idea. Git cloning means pointing to an existing repository and make a copy of that repository in a new directory at some other location. The original repository can be located on the local file system or on the remote machine, accessible supported protocols. The git clone command is used to create a copy of an existing Git repository. In very simple word, Git branches are individual projects within a Git repository. Different branches within a Git repository can have completely different files and folders. Or it could have everything the same except for some lines of code in a particular file. The next question is, what are the different ways by which you can refer to a commit? So in Git, each commit has a unique hash. These hashes are used to identify the corresponding commits in various scenarios. For example, while trying to check out a particular state of a code using the git checkout hash command. Along with this, Git maintains a number of aliases to certain commits known as the refs. Also, every tag that is created in this repository effectively becomes a ref, and that is exactly why you can use tags instead of committing hashes in various Git commands. So Git also maintains a number of special aliases that are changed based on the state of the repository. So in Git, commits are allowed to be referred to as relative to one another. In case of merged commits, where the commit has two parents, the raise to sign can be used to select one of the two parents. However, these can also be used to refer to commits that reside on remote branches, allowing one to control and manipulate them from the local Git environment. The next question is, what is the difference between rebasing and merging? So in Git, the rebase command is used to integrate changes from one branch into another. It is an alternative to the merge command. The difference between rebasing and merging is that rebase rewrites the commit history in order to produce a straight linear succession of commits. Merging is Git's way of putting a forked history back together again. The git merge command helps you take the independent lines of development created by Git branch and integrate them into a single branch. The next question is, mention the difference between revert and reset. So reset is used to return the entire working tree to the last committed state. This will scrap commits in a private branch or throw away uncommitted changes. Reset changes which commit a branch head is currently pointing at. It alters the existing commit history. So this command can also be used to unstage a file. Whereas git revert command creates a new commit that undergoes the changes from a previous commit. So this command adds new history to the project. It doesn't modify the existing history. Now we will talk about the advanced level of interview questions. So the question here is how to squash last n commits into a single commit. So there are two options to squash last n commits into a single commit, and you should mention both of these options while answering such questions. So in the first option, if you want to write the new commit message from scratch, you should use the following command. As you can see here on the screen, git reset, soft head, and git commit. And in the second option, if you want to start editing the new commit message with a concatenation of the existing commit messages, then you need to extract those messages and pass them to git commit. And for this purpose, you will use the command git reset, soft head, and this command git commit edit -m and the entire log command git log format reverse and the name of the head. The next question is, what is git bisect? How can you use it to determine the source of a bug? So Git Bisect is used to find the commit that introduced a bug by using a binary search. So the command for Git Bisect is pretty simple. As you can see on this slide, Git Bisect, subcommand, and the options. This command uses a binary search algorithm to find out which commit in your project's history introduced a bug. You can use it by first telling it a bad commit that is known to contain a bug and a good commit that is known to be before the bug was introduced. Then Git Bisect picks the commit between these two endpoints and asks you whether the selected commit is good or bad. So it continues narrowing down the range until it finds the exact commit that introduced the change. So the next question is, how do you integrate Git with Jenkins? So as you can see on the slide, these are the 4 steps that you can follow to integrate Git with Jenkins. And I'm also going to show you the screenshots for these 4 steps. So for anyone who's aware of Jenkins or has used Jenkins, you must be aware of this homepage or the Jenkins dashboard. So here you need to click on Manage Jenkins. And once you click on Manage Jenkins, you'll find this option here, the Manage Plugins option. Click on that. And then you will have to search for the plugin here. As you can see in this screenshot, click on this plugin. And here you have these 2 options, install without restart, download now, and install after restart. So you can choose any one of them. And once you're done with that, here you will be able to see this plugin that we have just downloaded along with its version number. So these are the steps that you must follow to integrate Git with Jenkins. So the next question is, how do you configure a repository to run code sanity checking tools right before making commits? So here you must first mention what exactly is sanity checking. A sanity or a smoke test determines whether it is possible and reasonable to continue testing. And now you must explain how do you achieve this. So this can be done with a simple script related to the pre-commit hook of the repository. The pre-commit hook is triggered right before a commit is made, even before you're required to enter a commit message. So in this script, one can run other tools such as linters and perform sanity checks on the changes being committed into the repository. So as you can see here, this is the script that I'm talking about. The purpose of the script is that it checks to see if any .go file that is about to be committed needs to be passed through the standard Go source code formatting tool. By exiting with a non-zero status, the script effectively prevents the commit from being applied to the repository. The next question is, what is git cherry pick? The command git cherry pick is normally used to introduce a particular commit from one branch within a repository onto a different branch. Another common use of this command is to forward or backport commits from a maintenance branch to a development branch. This is in contrast with the other ways such as merge and rebase, which normally apply many commits onto the another branch. So the syntax for this command is very simple. You just need to type git space cherry -pick space the commit hash. The next question is, what is git reflog? The reflog command keeps a track of every single change made in the references, that is the branches or the tags of a repository, and keeps a log history of the branches and the tags that were either created locally or checked out. Reference logs such as the commit snapshot of when the branch was created or cloned, checked out, renamed, or any commits made on the branch are maintained by Git and listed by the reflog command. So this command must be executed in the repository that has the lost branch. So if you consider the remote repository situation, then you have to execute the reflog command on the developer's machine who had the branch. So the next question is how to recover a deleted branch using the git reflog command. So here, as you can see on the screen, these are the 3 steps that you must follow to recover a deleted branch. And I'm also going to show you the screenshots. Okay. So in the first step, you get the history logs of all the references. For that, you just need to type git reflog. And once you type this command, you can see the history log. In the second step, you need to identify the timestamp of the branch that you want to recover. So here in this case, this is the timestamp that we are looking for, the pre-prod branch. Here in the third step, you just need to use the command git checkout -b and the branch name. This is a pointer reference when the pre-prod branch was created. So if you follow these three steps, you will be able to recover the deleted branch. So the last question of this session, that is, mention some of the git reflog subcommands. So as you can see on the screen, these are the commands that we will talk about, 4 to 5 commands. The first command is git reflog help. So this command is used to open up the manual page. The second command is the git reflog show. So this command shows the logs of the references provided in the command line. The third command is the git reflog expire. So this command is used to prune the older reflog entries. The fourth command is the git reflog delete. So as the name suggests, this command deletes single entries from the reflog history. And the fifth command is git reflog exists. So this command checks whether a reference, that is a branch or a tag, has a reflog log history entries. So these were a few commands like git reflog subcommands that you can answer in this question. So with this, we have come to the end of this session. I hope you have enjoyed this session. If you have any queries related to this session, you can post them in the comment box below, and we will try to get back to you as early as possible. Till then, happy learning. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!